What if I told you that the universe isn't made of matter, but of questions, that space might be a projection, time might flow backwards, and reality itself could depend on who's watching? That particles can vanish and reappear, effects can come before causes, and the laws you think are fixed might only be suggestions whispered by uncertainty. These aren't science fiction plots. They are real phenomena confirmed in the deepest layers of quantum theory, where logic breaks and truth becomes personal. Over the next 4 hours, you'll journey through paradoxes that feel impossible but are proven, experiments that shatter common sense, and theories that suggest reality is stranger than anything you've ever imagined. So if you're ready to let go of what you think is real, question the nature of existence, and enter a universe where nothing exists on its own, not even you, then tap like, hit subscribe, and step into the quantum unknown, where the rules dissolve and everything depends on how and when you look. The holographic principle is the universe projected from the edge. You've always felt like you inhabit space, like your body is suspended inside a vast container called the universe, solid, expansive, real. You feel the pull of gravity in your bones, the pressure of wind on your skin, the distance between stars as immeasurable stretches of emptiness. You think you are in the world, like a character inside a stage, acting out your life within the dimensions of height, width, depth, and time. But what if you were never truly inside anything? What if everything you know, everything you touch, everything you are, wasn't actually embedded in space, but painted onto its surface like an illusion too perfect to question? What if your experience of depth, of movement, of identity itself, was just the inner echo of something stored far away from a boundary you'll never reach, let alone see? The holographic principle doesn't just stretch your imagination, it breaks it. It suggests that all the information contained in a three-dimensional volume of space, including everything that exists inside that space, your cells, your thoughts, the stars above, is actually encoded on a two-dimensional surface at the edge of that region. Not metaphorically, not as a metaphor for spirituality or mind-body duality, but physically. Just like the surface of a holographic plate contains the full image of a three-dimensional object, even though the plate itself is flat. In this view, reality doesn't unfold inside space. Space itself unfolds from something deeper, from the edges, from the information written onto the cosmic boundary. It means that you, sitting there right now, might be the result of a pattern flickering on a shell of reality unimaginably far away. And if that sounds impossible, it's only because your intuition was never built to understand it. This principle was born not from mysticism, but from the mathematics of black holes, those gravitational abysses that devour light, matter, time. In the 1970s, physicist Jacob Bekenstein discovered something strange. The entropy, or information content, of a black hole didn't scale with its volume, but with its surface area. Stephen Hawking's calculations confirmed it. The stuff inside a black hole, the measure of its information, seemed to be stored on its event horizon, the outer boundary beyond which nothing returns. That was the crack. The crack that spread through physics like a slow quake, until theorists began to ask, what if this is not unique to black holes? What if all space behaves like this? What if the universe itself is like a black hole turned inside out, and everything you see and know is just a projection from a distant, enclosing edge? It's an unsettling reversal. The inside, the world of experience, becomes secondary, and the outside, once thought to be empty or irrelevant, becomes the source. This is not a philosophical speculation. It's part of cutting-edge string theory and quantum gravity. The ADS-CFT correspondence, formulated by Juan Maldacena in the late 1990s, mathematically shows that a gravity-filled universe inside a volume can be fully described by a quantum field theory with no gravity on its boundary. It's not just like a hologram, it is one. So you ask yourself, if a full reality can arise from boundary conditions alone, What does that make you? A volumetric illusion. A walking, thinking, feeling light pattern. But what does that mean for your sense of self? If you're just a projection, are you less real, or is your reality more complex than you imagined? After all, the holographic image is no less beautiful for being a trick of light. Its beauty lies in the coherence of the illusion, in the seamlessness with which information from the edge unfolds into depth. Your emotions, your choices, your memories, if they are part of this unfolding, they are not meaningless. They are the texture of the projection, but it raises deeper questions. If reality is written on a surface, where is that surface? What does it look like? Is it physical or mathematical? Could it be something like a cosmic ledger, a boundary lattice, a veil humming with bits of quantum data? And who or what? Upon it, the idea of a projected reality makes you wonder if your every action is not only visible, but encoded, preserved like grooves in a record that plays your existence from some unreachable vantage point. Do you live inside a story that is being read from the outside? Is the arrow of time your past, present, future just the process of decoding that script, line by line? If you are a projection, then what does it mean to suffer, to love, to fear death? Is your pain still yours, if it's written on a cosmic sheet of information? You may feel tempted to dismiss this theory as cold or dehumanizing, as if it robs you of substance. But what if it's the opposite? What if it means that your essence can never be truly lost, because it's imprinted onto the very fabric of reality? In the holographic model, even when the inside is destroyed, as in the case of matter falling into a black hole, the information is never lost. It persists on the boundary. If that principle holds, then your story may not vanish with your body. Your patterns, your consciousness, your singular way of being could be part of the cosmic tapestry, woven into its perimeter. This doesn't mean you are eternal, but it does suggest that your presence leaves a trace, one more fundamental than atoms, more resilient than flesh. A kind of ontological fingerprint etched onto the horizon of being, and maybe that's why you sometimes feel like there's something more, something just beyond perception, a sense that you are part of a deeper order. Not because you are spiritual or enlightened, but because, quite literally, your life is embedded in something you cannot see, but that sees you entirely. And yet, there's a kind of loneliness to it. If all of this is a projection, then so are the people you love, so is the warmth of sunlight, the gravity of tears, the softness of skin. So is meaning, so is hope. It forces you to ask, if everything is a projection, what is real? Is real even the right word anymore? Maybe reality is not what resists you, but what responds to you. Maybe it's not the atoms beneath your fingertips, but the attention they pull from you, the way you care, the way you ache, the way you hope. Maybe that's the one thing a holographic projection cannot fake. The experience of being aware, because while your body may be encoded, and your surroundings simulated through quantum math, your awareness of this illusion, the feeling of asking this very question, is a flame nothing on the edge can fully explain. The edge may contain the script, but it cannot know what it's like to be read. That's your job. That's consciousness. That's you. So what now? If this is true, if you are not inside the universe but instead of it, a blossoming of something written on its perimeter, how do you live differently? Maybe you begin to care more about what gets encoded. Not just your actions, but your attention, your integrity, your questions. Because if your reality is projected, then what you bring into focus becomes the only thing that collapses into meaning. Like a light beam through a slit, forming an interference pattern only when it's observed. Your choices matter. Not because they last, but because they echo, they shape the script, they rewrite the code. And perhaps that's the ultimate irony, that a projected being still has agency. That your will, your gaze, your compassion, are not just part of the hologram, they are what give it coherence. So the next time you stare into the sky and feel small, remember, you are not drifting within the universe. You are woven into its edge. You are the shimmer on its surface. You are a ripple in its boundary, a song played by its code. You are not less for being projected. You are miraculous for appearing at all. And if reality is only ever real at the edge, then the question that remains haunting, thrilling, unanswerable, is this: if the universe is the hologram, then what is the light? Is consciousness a quantum phenomenon? You've always assumed your mind was the result of your brain, the wrinkled biological control center locked behind your skull, firing electrochemical signals that somehow become thoughts, memories, emotions. But what if your consciousness wasn't confined to that physical tissue at all? What if the you that feels, dreams, decides, and doubts isn't a product of neurons alone but of something far stranger? What if your awareness arises not from biology, but from quantum mechanics? From the same forces that allow particles to exist in two places at once, to entangle across galaxies, to remain undefined until observed. Imagine this, that the flicker of your selfhood, the vivid hum of being you is not bound to flesh, but born in the microscopic shadows of quantum superposition inside your neurons. That at the very core of your brain's processing, there exists a place so small, so delicate, that the rules of the classical world dissolve entirely, and in that silence, consciousness blooms. This is not science fiction. It's the heart of the ORCOR, theory-orchestrated objective reduction, proposed by physicist Roger Penrose and anesthesiologist Stuart Hameroff. They suggest that inside the microtubules of your brain cells, teeny, cylindrical protein structures, coherence occurs. Not just electrical firing, but entangled computations across a quantum network, like a miniature cosmos within your skull. And when these quantum states collapse through a process they call objective reduction, it gives rise to moments of conscious awareness. Your sense of I might not be the voice of neurons, but the music of quantum collapse, sudden, orchestrated, emergent. To understand what that means, you have to step away from everything you've assumed about what it means to be a mind. You were told consciousness was an emergent property, just something that happens when enough complexity builds up in a brain, like heat emerging from friction. But this theory says no. It suggests consciousness is not a byproduct. It's not an illusion. It's not a convenient side effect of evolutionary wiring. It's something deeper, something primal, something rooted in the very structure of reality. In quantum mechanics, particles can exist in multiple states simultaneously, a phenomenon called superposition. But when observed, this cloud of possibilities collapses into one outcome. The question that haunted generations of physicists was, what causes this collapse? Why does a particle choose one reality over another? Penrose believed the answer was tied to gravity. That space-time itself resists indefinite superposition. That there is an objective threshold beyond which the universe forces a resolution. That moment when potential becomes actual is called objective reduction. And when it happens within the organized quantum structures of your brain's microtubules, it produces a moment of awareness, not thought, not memory, but that first flicker of I am. According to ORCOR, you are not conscious because your brain is complex. You are conscious because your brain allows quantum events to occur in just the right way, at just the right scale, with just the right timing, over and over again. This vision of the mind is terrifying and beautiful. It means that your awareness might be a quantum process, delicate, fleeting, non-linear, and fundamentally not. That what you feel as the indivisible now might be a quantum event, a collapse of countless intertwined possibilities into one coherent moment. And it gets stranger. Quantum mechanics allows for entanglement, particles bound together across space, their states linked, no matter the distance. Orco R implies that consciousness, too, may be entangled across your brain. That different parts of your mind may synchronize not by direct communication, but by quantum coordination. That the unified you experience the seamless integration of sound, sight, emotion, memory, is not a miracle of neural architecture, but a quantum symphony. Every note, entangled with every other, collapsing in rhythm to produce the feeling of now. And maybe, just maybe, the consciousness you carry is not wholly yours, not bounded by your skull. If microtubules in your brain access the quantum field, then who's to say that your awareness is truly local? What if what you call self is an interference pattern in a field that stretches beyond your body, beyond time? What if your thoughts ripple through a shared medium we don't yet know how to name? And suddenly, the implications unravel into something even more profound. Because if consciousness emerges from quantum events, then what happens when you sleep? When you dream? When anesthesia silences your mind? When you die, do the quantum structures cease? Or do they shift, reconfigure into another pattern? Is there continuity in the collapse? Or does each moment of awareness blink into existence alone, like a firefly in a forest of noise? The theory doesn't pretend to answer these questions, but it opens the door for a new kind of inquiry. One where life is not just biological, but informational. Where death is not just the end of function, but the dissolution of a quantum pattern. And in that light, your existence becomes more delicate and more astonishing. You are not simply matter arranged in complexity. You are a pattern in a field. A resonance. A transient coherence that rises, experiences, reflects, and fades. And that perspective does something strange. It changes how you feel the passage of time. If your consciousness is a sequence of quantum collapses, then time is not a river you move through, but a beat that emerges from the rhythm of collapse. You are not flowing, you are pulsing. And what does that mean for free will, for identity, for love? If your decisions arise from quantum fluctuations, are you free or are you chaotic? If your memories are stitched from moments of quantum collapse, is your past solid or probabilistic? And if your consciousness is a shimmer in an invisible field, is love a connection between bodies or between entangled minds? These are not idle speculations. They are philosophical detonations. Because if Orco R is right, it means you do not merely experience the world. You participate in its unfolding. Your awareness is not just a witness, it's a collapse point, a local moment of resolution in the cosmic dance of probability. Your mind doesn't just live in the universe, it helps decide what the universe becomes. And maybe that's what the ancient mystics intuited when they spoke of being one with everything. Maybe it wasn't poetry. Maybe it was physics, waiting to be understood. But even as this theory dazzles with its implications, it remains unproven. The evidence is suggestive, but not definitive. Microtubules may support quantum coherence. Conscious experience might be tied to orchestrated collapse, but nothing is certain. And perhaps that's the point. Because what Orco R gives you is not just a theory, it's a mirror. It forces you to look at your mind, not as a computer, or a puppet, or a ghost, but as a miracle of coordination, a place where physics turns inward, a site where the laws of nature become aware of themselves. And maybe that's the most extraordinary implication of all. That your consciousness is not a mistake. Not an afterthought. Not a computational glitch. It's the point. The place where the universe, for just a moment, folds in on itself and says, I am. So now you're left with a question that no equation can answer. No MRI can reveal. No neural scan can resolve. If your awareness is a quantum phenomenon, then who or what is collapsing into you? And when you close your eyes and feel the echo of presence, the breath behind thought, the light behind perception, are you looking into your own mind or into the quantum field dreaming you into being? Bell's theorem: reality must be non-local or not real at all. You've been taught to believe that the world is made of things solid, local, knowable things, that what happens here has no instantaneous effect on something over there. That reality behaves like a map, orderly, with distance separating cause from consequence. But what if that entire framework is broken? What if the world doesn't respect space the way you think it does? What if distance is irrelevant, and what's real can ripple from one place to another without crossing the space in between? What if two particles, no matter how far apart, could behave like synchronized dancers, responding not to signals or chains of cause, but to a deeper, hidden order, one that defies your understanding of time, space, and truth itself? This isn't speculation. It's the heart of Bell's theorem, scientific revelation so profound, it splits the concept of reality in two. John Bell, a quiet physicist with a taste for paradoxes, showed that if the universe obeys both realism, the idea that things exist independently of observation, and locality, the idea that no information travels faster than light, then certain correlations between particles should never exceed specific limits. But in lab after lab, those limits have been shattered. Quantum experiments, from ailing aspects in the 1980s to countless modern refinements, confirm it. Nature violates Bell's inequalities. The universe is either non-local or not real. Not real in the way you assume it, is not grounded in properties that exist before you look. Not real in the classical, comforting, Newtonian sense of a world out there that unfolds independently of your eyes. To understand the implications, you have to enter the strange theater of quantum entanglement. Imagine creating two particles in such a way that their properties are perfectly linked. If one spins up, the other spins down. You separate them, send one to the other side of the lab, or the other side of the galaxy. Then you measure one. Instantly, the other's state is known, even if it's light years away. It's not that the second particle updates in response, it's that it wasn't defined until you looked. Your measurement here determines reality there. Bell's theorem tells us this isn't due to hidden variables or pre-agreed instructions. The math forbids it. The only possibilities left are unsettling. Either information travels faster than light, violating relativity, or the particles don't have properties until measured, meaning reality itself doesn't exist until you engage with it. And the universe doesn't flinch. It keeps showing you this truth, again and again. In every test of quantum mechanics, that the fabric of existence is stitched with threads that loop outside space. That reality is built not from particles and fields, but from relations that have no anchoring in space at all. So now you're caught between two options, and both are disorienting. Non-locality means that the universe is intimately connected in ways that defy geometry. That something you do here can affect something far away, not through a force, not through a signal, but through a shared identity that was never truly split. That all division is superficial. That there and here are illusions of scale, not fundamentals of nature. On the other hand, abandoning realism means accepting that particles don't have defined states before you look. That the moon may not exist when no one is looking. That reality isn't a backdrop, but a performance. And you are part of the act. These aren't just technical distinctions. They reach into your understanding of what it means to exist. Because if reality isn't local, then everything is potentially touching everything else. If it isn't real before you look, then you participate in creating it. Suddenly, you're not just in the world, you are entangled with it. You are part of how it becomes, and this leads to questions you can't easily escape. If observation is necessary for defining reality, then what does that say about your perception? About your attention? About the gaze you carry into every room, every memory, every cell? Are you collapsing the world into form every time you look? If so, then consciousness is no longer a spectator, it's a sculptor. Your awareness, limited as it seems, might be an event horizon across which potential becomes actual. You don't just witness the spin of a particle, you decide which spin gets chosen. And if this is true on the smallest scales, what does it say about the larger ones? About the choices you make, the people you love, the version of yourself you believe in. Maybe they, too, only come into being through acts of observation, through focused, deliberate presence. Maybe nothing is stable until you see it. And maybe you're never fully seen, never fully defined. Unless someone else looks back. Bell's theorem doesn't just rewrite physics, it peels back the veneer of separateness. It whispers that what you call distance is a trick of perspective. That space is not the barrier you think it is. And if particles are linked across the cosmos, maybe minds are too. Maybe your sense of isolation is an error of scale. Maybe grief, intuition, Dacia Vutha, strange feelings that skip rational explanation, are not fictions, but faint echoes of a deeper connectivity. One that no map can trace, but every soul intuits. Maybe we are not individuals, but expressions of a web that pulses beneath time, each of us a vibration in a field that is fundamentally whole. That's what non-locality implies. Not just spooky action, but spooky identity. That nothing is alone, that everything is already in relation. That you, right now, are not outside the particle you've never seen, you are inside its context. Your being ripples through the universe whether you notice it or not. And yet, the mind rebels. You want a universe you can touch, measure, define. You want things to be where they are, to have properties, regardless of your presence. But quantum physics doesn't offer that comfort. It says the world is stranger than you ever dreamed and that it's still consistent. Predictable, yes, but not explainable in classical terms. And in that gap between prediction and understanding, something new emerges. Wonder, not the wonder of ignorance, but of confrontation. Confrontation with the fact that your logic has limits. That your metaphors, your senses, your inherited beliefs, too small to hold what is. Bell's theorem is not just a scientific result, it is a mirror. It shows you the edges of your worldview and invites you to step beyond. So here you are, suspended in a cosmos that obeys no map, living in a body made of particles that only become themselves when touched, carried by thoughts that ripple across a reality you cannot fully define. You're told by equations that the world is whole, but your experience feels fragmented. You're told that entanglement connects everything, but you still feel alone. You long for meaning, but the universe offers only structure, and yet, perhaps structure is meaning. Perhaps your attention, your choices, your moments of love or sorrow are not small within this quantum sea, but are the very acts that give it coherence. And maybe this is what Bell's theorem demands. Not that you solve the paradox, but that you live inside it. That you learn to walk through a world where things are connected beyond space, and real only when you care to look. And now the question remains not in mathematics, but in you. If the universe forces you to choose between things being everywhere at once, or not existing until you look, then what else in your life, your past, your identity, has only ever been real when you decided to see it? Quantum Darwinism, how reality survives observation. You live your life as if the world is always there and changing. Definite, silently existing, even when you're not looking. The chair stays a chair, the tree remains rooted in the ground, the stars continue burning above your sleep. But what if that constancy is an illusion? What if reality isn't a stable structure, but a survivor fragile arrangement that competes, evolves, and earns its place in your perception, through a hidden selection process beneath everything you see? What if the solidity you rely on is not a default, but a victory? In the strange mathematics of quantum mechanics, things don't begin as things, they begin as possibilities. Clouds of overlapping states, flickering between what they could be, until something new, an environment, a random particle forces them to choose. And yet, not all possibilities survive. Not every version of an object becomes real. Some decohere, some fade. Some are never seen, never remembered, never written into the script of experience. Quantum Darwinism suggests that reality, as you know it, is not simply revealed, it is filtered, selected from a wild, buzzing multitude of quantum possibilities, like organisms in a jungle of probability. What you call real is the outcome of that selection. The observable world is what remains after a cosmic game of survival, where only the fittest states, those that can replicate, persist, and spread their information across the environment, get to exist in your awareness. You don't see everything. You see what survived being seen. To understand this, you must leave behind the comfort of classical thinking. In quantum mechanics, a particle doesn't have a single position until it's measured. Instead, it exists in a superposition, a blend of possible locations. But if that's true, why do you only ever experience one version of reality? Why does the table have a precise shape, the sun a defined position, your hand a solid edge? The answer lies not in the act of observation, but in what gets passed on. According to quantum Darwinism, the environment acts like a witness, copying information about a system again and again into the world around it. A photon bounces off an object, carrying data. That photon hits another, spreads more data. Over time, only certain properties, called pointer states, get copied widely enough to become objective. Like a rumor repeated until it's accepted as truth, these states become the classical facts of the world. They are not necessarily the only truths, but they are the truths that win. You don't see superpositions because the environment suppresses them. It prunes the possibilities, amplifies the dominant branches, and leaves you with a world that feels coherent. But under that surface, the jungle still roars. Unseen versions of events, the ones that weren't copied, weren't reinforced, die quiet deaths in the darkness of probability. And that means reality isn't just observed, it's selected. This paints a picture, not of a passive universe, but of a Darwinian one. One where information competes for survival, and where your very experience is a fossil record of what endured. The implication is staggering. It suggests that reality, as you perceive it, is not absolute. It's the winner of an invisible competition. That cup on your desk exists, not because matter demanded it, but because information about it propagated effectively enough for you to see it. And the versions of the cup that were blurry, unstable, quantum, those were filtered out before they reached your brain. You only get the clearest copy, the most redundant, the most widespread signal. In this view, your consciousness isn't just receiving reality, it's receiving the final product of an information battle fought behind the curtain. A tree doesn't become real because you looked it, becomes real because billions of particles, scattering data into the world, selected its stable form. You walk through a landscape sculpted not just by gravity or biology, but by informational resilience. And this leads to deeper questions, not about physics, but about perception. If you see only what survived being seen, then what else might have existed, briefly, before vanishing into non-being? What versions of people, of moments, of choices, flickered for an instant in the quantum foam and then collapsed, not from observation, but from neglect? Could entire timelines have withered because their information didn't spread? If reality is built from redundancy, from consensus among environmental witnesses, then uniqueness is fragile. And if your memories, your identity, your sense of self, are just patterns surviving in your neural environment, then who are you, really? A persistence? A winner of selective attention? Are you the real you, or just the version that lasted? Quantum Darwinism doesn't deny objectivity, explains how it arises. It shows you how the blurry becomes sharp, how the possible becomes actual, how the flickering turns into the firm. But it also humbles you, because it means your version of reality is not the only one that could have been. It's the one that replicated best, and in that sense, perception becomes evolutionary. Belief becomes statistical. The table exists because enough photons agreed to report it. The tree is tall because its shadow was long enough to touch you. The world is what it is not because it must be, but because it was seen enough times, in enough ways, to leave no room for alternatives. You are not just an observer. You are part of the mechanism that confirms existence. Your attention, your memory, your ability to share experience, all of it, reinforces the winning states. The world becomes real when it becomes communal, and here's the twist. If what you observe becomes more real, the more it spreads, then perhaps what you choose to focus on matters more than you think. Perhaps kindness, love, forgiveness, if repeated, if copied, if spread, gain a kind of ontological weight. Perhaps fear and violence, if isolated, fade like unstable wave functions. If reality is sculpted by what survives observation, then your gaze is a sculptor's chisel. What you serially see may help determine what continues to be. And if that's true, then how you live becomes an act of curation, a quiet shaping of the world. Not through force, but through focus. So next time you open your eyes, ask yourself, what am I reinforcing? What am I letting fade? What version of reality am I helping survive, not just with my instruments, but with my attention? Because if quantum Darwinism is right, then the world you live in isn't merely given to you. It's one you help select. One that lives because you let it. The firewall paradox: does quantum theory burn black holes? What if the most terrifying truth about the universe isn't that it's vast, cold, or indifferent, but that its deepest laws might contradict themselves, igniting not just stars, but logic itself? What if reality, in its rawest form, contains a fracture so fundamental that even the most sacred principles, like the conservation of information, the smoothness of spacetime, and the unyielding nature of quantum theory cannot all be true at once? You've likely heard that falling into a black hole would be strangely uneventful. A silent transition across an invisible boundary, where nothing particular happens, at least not right away. According to general relativity, the event horizon is not a barrier but a point of no return, a border etched in geometry, not fire. But quantum mechanics, with its sharp insistence on information preservation, whispers a darker tale. It suggests that at that very edge, where gravity reigns and light falters, there must be a rupture. A violent firewall of unimaginable energy that disintegrates anything before it even dares to cross. Not in metaphor, but in raw, searing quantum fire, a paradox arises, and you are not outside of it. You're inside, trying to reconcile three truths that cannot coexist. That information is never lost. That physics remains smooth at the horizon, and that black holes radiate and evaporate. Choose any two, and the third shatters. This is the firewall paradox, not just a cosmic riddle, but a philosophical crisis in the shape of a dying star. And if that sounds distant, impersonal, too big to care about, think again. Because this paradox isn't just about distant black holes, it's about what happens when the truths that define your identity come into conflict. It's about the stories you tell yourself to stay whole, even when parts of those stories burn in contradiction. Picture yourself drifting toward a black hole. The stars behind you stretch into silence, and ahead nothing. No surface, no sound. Just the edge of the known, a quiet line where light forgets how to escape. Relativity tells you nothing will happen. Quantum theory insists everything will, and between these two giants, your fate splinters. If the firewall exists, it's not just a curtain of heat, it's A scream from the universe that says, I cannot be everything at once. The smooth curve of Einstein's spacetime cannot contain the jagged edges of quantum truth, so the event horizon, once thought to be passive, becomes active, aggressive, violent, and that tells us something more terrifying than fire, that our theories are not complete. That even our most trusted equations hide contradictions as deep as any. Singularity. Hawking radiation says black holes slowly leak their contents in the form of thermal particles. But thermal radiation carries no information. If a black hole disappears completely, where does the information go? If you say it vanishes, you violate quantum mechanics. If you say it escapes, you violate relativity. If you say the laws change, at the horizon, you invent a firewall. And so we teeter at the edge of understanding, caught in a cosmic logic loop that may have no resolution, only consequences. Maybe the paradox is a map, not a trap. Maybe it points toward a deeper theory, one not yet born. String theory, loop quantum gravity, holography each offers glimpses of salvation, but none are whole. The ADS-CFT correspondence suggests that black holes might be fully described by a lower dimensional surface, storing information like a cosmic hard drive, but this too raises questions. What does it mean for your reality if the interior of a black hole is just a projection? What does it mean for you if your own experience is only ever the outside of something deeper? Because the firewall doesn't just separate space, separates philosophies. On one side, you have the smooth determinism of space-time. On the other, the unpredictable dance of quantum chaos. In between, fire. And you're in the middle, not falling into a black hole, but living in one, metaphorically. Your identity, too, might be governed by horizons, by contradictions you refuse to see. You believe in truth, but you lie to protect it. You believe in memory, but forget selectively. You believe in self-consistency, but live with opposing beliefs daily. And perhaps, like the universe, your peace requires a firewall, a place where contradiction burns before it can consume you. But is that healthy? Is that sustainable? Or will your inner singularity eventually demand coherence, the way physics does? Physicists have tried to soften the paradox. Some suggest quantum entanglement provides a secret bridge, that the information inside the black hole is not lost but mirrored in the radiation it emits. Others argue that new principles like EREPR, which connects wormholes to entanglement, might allow for reconciliation without flame. But these ideas are young, tentative, and the fire still looms. And so we live in the tension, in a universe that permits black holes to exist, but not their full explanation. A universe that whispers its deepest truths in contradictions. And what does that say about us? That maybe we too are creatures made of unresolved dualities. That maybe to be conscious is to contain mutually exclusive beliefs. That maybe to be human is to be a paradox in motion. And so the firewall becomes more than a theoretical boundary, it becomes a metaphor for the points in life where logic fails and feeling takes over. Where your emotional truth violates your intellectual one. Where the stories you need to survive burn the facts you cannot deny. In the end, the paradox remains unsolved. Not because physics has failed, but because we are not yet ready to ask better questions. And maybe that's the message the universe is sending, that the edge of understanding is always on fire, and you must risk walking through it to find what lies beyond. But if the cost of truth is burning the framework that carried you here, are you ready to walk through the flames? Or will you linger at the event horizon of your own life, suspended between what you know and what you cannot yet bear to learn? Because sometimes, the only way to preserve what matters is to let it be transformed by fire and hope that what survives is not the same, but more true. So ask yourself, in the face of contradiction, will you defend what's familiar, or will you embrace the burn? Is reality made of information? What if everything you've ever touched, everything you've ever seen, everything you've ever known, your body, your memories, the stars above you, and the time ticking inside you weren't made of matter at all, but of something far more ghostly and abstract? Information, not atoms, not energy, but bits, a yes or a no, a 1 or a 0, a flicker of meaning floating in the void. You were taught that the universe is built from particles, tiny billiard balls, bouncing in space, obeying laws of nature like obedient dancers in a cosmic choreography. But what if those particles are not the foundation, only the illusion? What if underneath them, deeper than the quantum foam, more fundamental than strings or space-time, lies nothing more than a digital whisper? A pure distinction, a binary choice, a bit of information. You look at your hand, expecting to see cells, atoms, quarks. But what if all that's really there is a pattern of structure written in code? What if the universe is not a machine, but a message? What if you are not made of matter, but of meaning? The idea isn't science fiction. It's known as the it from bit hypothesis, and it has haunted the minds of some of the greatest physicists of the last century. Proposed most famously by John Archibald Wheeler, a colleague of Einstein and a pioneer of black hole physics. The phrase captures a radical possibility that every it, every particle, every force, every field, every chunk of space-time derives its function, its existence, even its reality, from a fundamental yes-no answer to a binary question. Reality, at its root, might be a series of choices, recorded, stored, and echoed across the fabric of space. Imagine a photon traveling across the cosmos, a ghost of light born in a star, and aimed by chance, or fate at your eye, it flies. For billions of years, unmeasured, undefined, a superposition of all possible paths. But the moment it hits your retina, your telescope's mirror it chooses, it snaps into place. The wave becomes a particle. A bit becomes an it. Your observation doesn't just reveal reality, it helps create it. Like a cosmic coin flip that only becomes real once someone sees heads or tails. And this isn't just poetic musing. In quantum mechanics, it's baked into the math. Until measurement, a particle is described by probabilities, by maybes, by a range of options that all exist at once. But measurement collapses the wave. It answers the question. It selects one path from the infinite. It creates a fact. And what is a fact, if not a bit of information? This leads to a strange thought. The universe may not be a thing you exist in, but a conversation you are part of. Reality may not be a place, it may be a process. A flowing dialogue of questions and answers, bits flipping, decisions crystallizing into space and matter. And that raises even deeper questions. If the universe is made of information, then what is doing the computing? Who, or what, is asking the questions that turn maybes into is? Is it us? Are we part of the machinery, or are we the audience? Or maybe the boundaries between observer and observed dissolve entirely, and reality is not a play acted out for you, but one you help write with every glance, every breath, every thought. You might wonder, can we see this information directly? Can we peel back the layers of physics and glimpse the code underneath? Some believe we can. Theoretical frameworks like digital physics propose that space-time itself is a kind of computational lattice, a grid of information nodes, updating themselves at Planck-scale intervals. The pixels of reality, every electron, a data packet, every quantum jump, a logic gate. In this view, the laws of physics aren't just rules, they're algorithms. Constants, like the speed of light, or Planck's constant, become lines of code. Nature becomes software, and black holes, they might be the most literal expression of the it from bit idea. When matter falls into a black hole, the information it contains doesn't disappear, it gets encoded on the event horizon. Like a hologram, the surface remembers. Stephen Hawking's paradox about lost information gave rise to the holographic principle. The idea that everything inside a volume of space can be described by information encoded on its boundary. You are a volume of space. What if everything you are is stored on the surface that surrounds you? What if your mind is not confined to your neurons, but etched into the information pattern of the cosmos? If information is truly the substrate of everything, then consciousness itself might be a kind of compression algorithm, a self-referential loop of awareness encoded in the language of bits. In that case, thoughts are not just brain states. They are information transformations. Awareness is an emergent pattern born from recursive encoding, feedback, and interpretation. You become the reader and the story. But where does this rabbit hole end? Can something as raw and sterile as bits truly explain beauty, love, suffering? Can information alone account for meaning, or does it merely carry it? Are we confusing the map for the territory, the symbol for the soul? Or is this discomfort exactly the point? That meaning arises, not despite abstraction, but because of it. After all, your DNA is just a 4-letter alphabet, written in chemical code. Your memories are electric echoes. Your words are vibrating air. You've always been information, dancing in form, and yet, you feel. You love, you suffer. If information can feel, then perhaps the universe itself is not just made of thought, it's thought. Or maybe we're missing something deeper still. Maybe bits are not the bottom. Maybe bits themselves arise from relations, from context. A bit only makes sense if it means something to someone. A question is only a question if there's a mind to ask it. Does that mean minds are fundamental? That consciousness isn't a side effect of information, but its source? This flips everything upside down. Instead of the universe birthing observers, maybe observers birth the universe. Maybe the reason things exist at all is because someone is watching, someone is wondering, someone is asking the primordial question, is it or isn't it? In that case, you aren't just a result of information, you're its author. Not because you choose the laws of physics, but because you choose to look, to wonder, to ask. In the end, the it from bit hypothesis doesn't just redefine physics, it reframes your place in the cosmos. You are not a passive lump of matter drifting through space. You are an active participant in a story of meaning-making that spans galaxies and quarks alike. You are the question and the answer, the signal and the decoder, the pattern and the presence. And maybe, just maybe, when you close your eyes and reach out with your thoughts, what you're touching is not empty space, not silence, but the raw, shimmering thread of the universe thinking itself into being. So the next time you wonder what you are made of, don't look for atoms or bones. Look for meaning. Look for the places where yes and no meet and dance. Where the world becomes real only because you asked it to be. Where every moment is a binary miracle, a breath drawn between question and answer. And ask yourself, if the universe is made of information, then what kind of message are you? Can you build a universe with just a quantum computer? What if everything you've ever known, stars, particles, gravity, thoughts, time could emerge, not from a divine architect or primordial chaos, but from a man-made machine, smaller than a watermelon and colder than outer space? What if a quantum computer, that fragile lattice of entangled qubits and vanishing probabilities, could hold not just your memories, but an entire cosmos law's life encoded in elegant logic? Gates whispering in superposition. What if the vastness of everything could fit inside a handful of qubits? This isn't fiction. It's a question that tears open the fabric of your assumptions. You were raised to believe that computers simulate the world, but they could never become it. That they could mimic a storm, but not summon rain. That they could calculate the structure of molecules, but never breathe atoms into being. But quantum computers aren't like the machines you grew up with. They don't just crunch numbers. They sculpt probabilities. They don't move bits. They bend reality. A classical computer is a library you flip through one book at a time. A quantum computer is the entire library reading itself simultaneously. And that power isn't just for faster emails or better movie recommendations. It's a gateway. A key to dimensions we've never physically touched. To understand how, you must first question what reality even is. Is it solid? Objective? Or is it something emergent, something that arises only when patterns coalesce into coherence, when relationships form between invisible things? Modern physics suggests that the universe isn't built from stuff, but from structure. From relations, from logic, from the entangled dance of fields and forces and feedback loops. And what better device to model such relations than a quantum computer machine that lives in a liminal space between existence and possibility, between is and maybe. In its qubits, states exist, not as binaries, but as clouds of probability, entangled with each other across invisible threads of correlation. When you run a quantum algorithm, you're not walking a single path, you're walking all paths, across all possibilities, and collapsing them into a single meaningful answer at the end. Doesn't that sound eerily like what the universe itself is doing? Think of the Big Bang not as an explosion of particles, but as an initialization. The boot-up sequence of a cosmic computation. The birth of a space-time operating system. Every moment since, every atom that formed, every star that burned, every cell that divided could be seen not as physical events, but as outputs of a deeper, non-physical computation. In this view, the universe isn't being simulated inside. A quantum computer is a quantum computation. The laws of physics, the software, the constants of nature, configuration parameters, time itself, a processing loop. You might feel a chill at that thought, because it suggests something profound, that we may eventually understand enough of this structure to replicate it. To recreate, in some controlled environment, the same kind of computation that gives rise to space, time, and matter. What happens when you don't just simulate a universe, but create a self-contained system whose internal logic mirrors our own cosmos so perfectly that it becomes indistinguishable? Could the beings inside such a system be conscious? Would they perceive up and down, life and death, choice and chance, just as you do? Would they build telescopes and see nothing beyond their edges, just like us? You may be tempted to think this is a metaphor, but it's not. Physicists like Seth Lloyd have proposed that the universe, viewed through the lens of quantum information, can be described as a finite computationer, sum of logical operations carried out since the origin of time. And if that's true, then building a universe with a quantum computer is not a poetic idea, it's a real possibility. Bounded only by our technological sophistication and understanding of initial conditions. But then, what does it mean to be real? If a universe runs within a quantum computer, and no one observes it from the outside, does it exist? If conscious observers emerge within it, unaware of their artificial origin, is their experience any less genuine than yours? And if we create such a universe, do we become its gods or its prisoners? Consider the nested implications. If we can build a universe from bits, then perhaps ours was built in the same way, not as a simulation, in the science fiction sense, but as a self-sustaining computation, a recursive, evolving structure, governed not by whim, but by necessity. And if that's true, then every law, gravity, thermodynamics, quantum entanglement is not just a description of how things behave, but a consequence of deeper rules you've yet to uncover. And quantum computers, in all their fragility, may be the tools that open that curtain. When you entangle qubits, you link them in ways that defy space. When you apply quantum gates, you perform transformations that rewrite what is possible. And when you measure an outcome, you collapse a multitude of realities into one. Is that not what consciousness itself does? Could it be that the mind is a quantum computer made of neurons? That reality is a dream being dreamed in probabilistic logic? That the moment you observe a thing, you do not just see it, you create its place in the world's unfolding structure? You begin to see that this isn't just about building an artificial universe. It's about recognizing the one you're already in. That maybe everything you've ever known is already a quantum computation. One you've mistaken for solidity because you are part of it, encoded into its memory and processing cycles. But here's the most dizzying question. If you could build a universe, should you? What ethical responsibility would you bear toward the emergent intelligences that arise within it? Would you be a benevolent creator or a blind one? Would your creation be paradise or purgatory? And how would you even know? After all, if you were created, would you know it? You live your life assuming you are the first cause, the origin of your thoughts, the author of your fate. But what if you are the product of an invisible process? A ripple in a code written eons ago, running not on silicon or in space-time, but on something deeper, a substrate beyond comprehension. You wouldn't feel fake, you'd feel exactly like this: alive, aware, yearning. The terrifying beauty of this idea is not that it reduces you to information, but that it elevates information to soul. That a quantum computation, given enough richness and recursion, might awaken, might love, might suffer, might dream. You are proof, because here you are, listening, wondering, reaching, not knowing whether your universe was born from a divine spark, a mathematical truth, or a cold machine, but still searching for meaning anyway. So the question isn't just, can we build a universe with a quantum computer? The question is, have we already? And the follow-up might be more personal. If someone else did, would you want to know? Wigner's friend paradox: when two observers see different realities. You're standing in a sterile white laboratory, beneath buzzing fluorescent lights, staring at a sealed box that holds not just a quantum experiment, but perhaps two versions of reality itself. To anyone passing by, it's just a container. But to you, and to someone else, inside another room observing the same experiment, from a different angle, it might as well be two different universes coexisting under one lid. Wigner's friend paradox is not just a thought experiment, it's a philosophical mirror that shatters our most basic assumptions about objectivity. Imagine this: a friend enters a lab, runs a quantum experiment, say, measuring the spin of a particle, and sees a definite result. To them, the particle's quantum state has collapsed. It has chosen a side. But to you, watching from outside, the entire lab and your friend are part of a quantum system that's still in superposition, both outcomes existing simultaneously. So which one is true? Has the particle chosen, or hasn't it? Has reality solidified, or is it still a blur of possibilities? You're no longer just asking questions about atoms. You're questioning the very scaffolding of what it means to know something. What is a fact? Can a fact be different for different minds? And if so, how many universes are being born from every disagreement? This paradox, proposed by physicist Eugene Wigner, slams you into the cold wall between the observer and the observed. It's like watching a movie you're also acting in, and realizing your script isn't the same as someone else's. Quantum mechanics says that particles exist in a cloud of probability until measured. But if one observer sees a result, and another considers the whole process still unmeasured, who decides what's real? You might assume that once something is measured, it's settled. But Wigner's friend says otherwise. It tells you that what's real for you might not be real for someone else. And this isn't just a philosophical twist, it's grounded in the math of quantum theory. Schrödinger gave us a cat that's both alive and dead. Wigner gave us two people who can't agree. on whether the cat is even in a superposition or not. It's not about cats, it's about you. It's about your perception, your knowledge, your faith in the stability of a shared world. So take a moment and think. What happens when reality becomes relative, not to the speed you're moving, like in Einstein's relativity, but to the knowledge you possess? You've always believed that reality is a shared platform, that facts are bricks we all stand on. But this paradox whispers something darker. That facts might be like shadows, stretching differently depending on who casts the light. If every observer has their own truth, then what connects us? What guarantees that the world you wake up to is the same one others wake up to? Is objectivity a comforting illusion? A negotiated consensus between brains trapped in separate heads? Or is it possible that each conscious observer lives inside their own unfolding cosmos, tied together only by assumptions we no longer dare to question? Imagine sitting across from a friend and asking them a question. They answer you. You nod. Conversation flows. But what if, in the quantum fog beneath your shared moment, their answer and its opposite both existed? What if, to them, they said one thing, but in your observation history, they said another? You wouldn't know. And even if you suspected, how would you prove it? Wigner's paradox isn't a glitch in the fabric of physics, it's a torch held to the curtain of consciousness. It makes you realize that what you observe isn't just influenced by your perspective. It might be defined by it. And that, more than anything, reshapes the contours of reality from a fixed map to a living, breathing negotiation. This paradox ties into something deeper, the question of what an observer really is. In quantum physics, observation causes wave function collapse. But what qualifies as an observer? A human, a measuring device, a camera. Your friend in the lab is undoubtedly conscious. But from your vantage point, until they report their result, they and the lab are still quantum. This suggests consciousness might play a unique role in collapsing possibilities into actuality. Are you a co-creator of the universe? Every time you look at something, is your awareness a sculptor that chisels certainty out of chaos? Or are you just another point of view, swimming in a sea of conditional truths? And if reality depends on observation, what happens when observers disagree? Is one of you wrong, or are you both right in your own universes? The implications here are staggering. In our everyday world, we demand consistency. Courts, science, relationships, everything relies on a shared agreement about what is real. But quantum theory pulls the rug out from under that assumption. It says that perhaps truth isn't a universal currency. Maybe it's local, maybe it's personal, maybe it's fragile, like a snowflake that melts under the heat of too much attention. This isn't science fiction. Experiments are being designed today to test Wigner's paradox in the lab. With entangled particles, delayed choice setups, and increasingly clever designs, physicists are pushing the boundary between the quantum and the classical, between the microscopic world of uncertainty and the macroscopic world you call home. And the deeper they go, the more reality feels like a hall of mirrors, where every observer is both reflection and source. You are not separate from the universe. You are entangled with it. And every measurement, every glance, every act of awareness is a thread pulling possibility into structure. But here's the hardest part to accept. If Wigner's friend is right, then consensus reality, the world we agree on, might be a compromise, a useful fiction, a stitched-together quilt of overlapping partial truths. What you see is real for you, but someone else's version might be equally real and fundamentally incompatible. We're not living in the same world. We're surfing different branches of the wave function, hoping we don't drift too far apart. And maybe, just maybe, we already have. So now you're left with the final quiet question. If reality requires a witness, and every witness shapes their own version of it, then what happens when you close your eyes? Does the world vanish, waiting patiently in superposition, or does it keep spinning, unaware of your absence, certain in its own unfolding truths? You'll never know for sure. Because just like Wigner and his friend, you and the world are forever dancing on the blurry edge between knowing and not knowing. Seeing and being seen, and maybe, just maybe, that's what makes you real. When quantum physics meets philosophy, do you create the world by asking about it? You think the world exists, regardless of you firm finished, waiting to be discovered like a stone buried beneath centuries of silence. But what if the very act of asking is what chisels that stone into shape? And your questions are not lanterns shining into an already built room, but brushes painting the walls as you walk. What if you don't just explore reality, but participate in its birth? If the universe isn't a book you're reading, but a script that responds to your voice the moment you speak. Imagine standing before a dark sea, where no land exists, until you wonder if there might be an island, and suddenly, one rises from the surf. Quantum mechanics whispers such stories, not of firm earth, but of waves of possibility, where particles don't settle into place until something observes them, until you peer into the void and ask, "Are you there?" And only then does the answer coalesce into something like matter. This is not mysticism wrapped in the language of science. It's physics brushing up against the edge of the unknowable, where equations do not describe certainty, but probability, where the cosmos is not a mechanism, but a maybe. In this strange framework, things are not until they are measured. Not here or there, not this or that, but a soft potential cloud of options, suspended like stars in fog until your curiosity collapses them into one choice. One now, one there, and suddenly you are not just a witness, but a sculptor, not just a passenger, but a co-author of what is. You've heard of the double-slit experiment, a single particle of light aimed at a barrier with two slits, expected to go through one or the other like a marble. But no, it behaves like a wave, like a ripple that interferes with itself, passing through both slits simultaneously. Unless you look, unless you observe, and then it acts like a particle again, choosing a single path. As if your very act of watching changes the story being told. As if reality waits for your eyes before deciding who it wants to be. So, you wonder, if a tree falls in a quantum forest, and no conscious mind is there to observe it, does it ever really fall? Or was it only a smeared-out possibility that never truly happened? And if that's true, what else in your world only comes into being because you expect it to, because you asked? Because you dared to turn your attention toward it and pin it down with meaning. Your house, your past, your relationships, even your memories. How many of these are facts, and how many are collapsed waves, sharpened into form only because your inner eye needed them to be? The philosopher's mind bends here, pulled like light into the black hole of mystery. Are you dreaming this life, or dreaming yourself into the shape of someone who believes they are awake? Are you the one asking the question, or the answer that formed the question, just to be heard? In the realm of quantum philosophy, the self and the universe dance in entangled rhythm. You shift, and the world echoes. You wonder, and the answer crystallizes. You doubt, and uncertainty blossoms again, like fog reclaiming the road. The classical world says reality is out there, definite and deterministic. But quantum theory suggests something far more haunting, that there is no out. They're independent of the in here. No firm wall between observer and observed. No guarantee that the moon is in the sky when no one is looking, except the comfort of old assumptions. And this isn't just poetic, it's embedded in the mathematics. In interpretations like the Copenhagen view, where particles have no set properties until measured. In the participatory anthropic principle, which suggests the universe must be the kind that gives rise to observers like you, because, without you, there would be nothing to know it ever existed. Even John Wheeler, the physicist who coined the phrase "it from bit," imagined a cosmos built not from particles or fields, but from binary choices, questions and answers. At the deepest level, he said, every physical thing may arise from an immaterial act of asking, yes or no, on or off, bit by bit. As if existence itself is a conversation between the cosmos and consciousness. You ask, and the universe replies. You look, and it appears. You think, and something takes shape. This view reshapes what it means to be alive. You are not just an organism inside a universe, you might be the axis around which it spins. You, the asker. You, the observer. You, the ripple that collapses. The wave into the moment. Not because you will it, but because that's how reality responds to presence. Does this mean nothing is real? No, it means real is not a fixed state, but a verb, an interaction, a co-creation. Reality is what emerges at the interface between your awareness and the unknown. And in that sense, there is no world without you, not in any meaningful sense. But does that make you God? Not quite. It makes you a participant in the sacred ani through which the cosmos sees itself. A voice through which the silent equations of the void are translated into experience. And what is more sacred than that? Still, you return to the question. Do you create the world just by asking about it? Maybe not create, but reveal. The way a sculptor reveals the form within the stone. The way a melody reveals itself when you dare to play a note. Your questions are keys, unlocking doors in the fog. Your attention is the light that casts shadows where nothing seemed to stand. And if that is true, every moment you are not just perceiving but shaping, then how carefully must you wield the gift of wonder? How sacred is the act of attention? How powerful is the mind that chooses what to see? The universe, in this view, is not a machine to master, but a mirror to approach with reverence. It shows you what you expect, hides what you ignore, morphs under the pressure of your gaze. So you ask again, when you look at someone you love, do they become more real under your eyes? When you doubt yourself, do you collapse into smaller versions of what you might have been? When you believe, does the universe bloom to meet your belief? These are not idle fantasies. They are echoes of quantum logic, woven into the strange grammar of the cosmos. And if all this feels impossible to believe, remember this: the world was never obligated to make sense to your mind. It only needed to respond to your attention. So maybe the ultimate truth isn't out there to be found, but in here, waiting to be asked. Maybe the deepest laws of physics are not laws at all, but invitations. Questions disguised as constants. Doors pretending to be walls. And maybe, just maybe, the world isn't waiting for you to understand it. It's waiting for you to speak, to reach, to wonder. And in the echo of your asking, the universe becomes just real enough to answer, yes, I am here, because you asked. Quantum gravity. Can space-time be quantized? You walk across the room and don't fall through the floor, not because you're solid, but because space itself is playing by rules you don't see. A silent scaffolding that holds your every breath, thought, and memory. You move through time as if it were a stream flowing one way, but what if time itself is a lattice, a grainy film strip clicking from one frame to the next? You assume space is smooth, continuous, infinite, but what if it's not? What if it's pixelated, chunked, granular, made of tiny units, so small you can never touch them, but they're touching you right now? You think of space and time as a backdrop, like a cosmic theater stage upon which reality plays out. But what if they're not the background but the actors? What if the stage itself is dancing, vibrating, collapsing, and emerging moment to moment, like a quantum creature, stitched together from uncertainty. This is the riddle of quantum gravity, a paradox so profound, it breaks the language we use to describe reality. Pulling apart the fabric of physics and revealing the threads of something deeper, something more abstract, more real, more strange. Because deep down, the universe is telling us that the very things we thought were the most reliable, the flow of time, the distance between 2 points, the geometry of space, may be illusions born from approximation. And if you want to understand what's underneath, you have to step into a world where even space itself can't be trusted to stay still. General relativity tells you space-time is a smooth, flexible fabric. Gravity isn't a force, but the bending of this fabric. Quantum mechanics tells you the world is granular, probabilistic, indeterminate. When you try to put them together, they scream. The equations explode, infinities bloom, like black holes in your math. Something is wrong. Something doesn't fit. And that contradiction has haunted physics for over a century. You can't describe black holes fully. You can't understand the Big Bang completely. Because where quantum mechanics should meet gravity, the most extreme places, the universe goes silent. It refuses to yield its secrets. But some physicists aren't afraid to ask, what if space-time isn't fundamental? What if it's emergent, like temperature, something that only makes sense when you average over billions of microscopic pieces? Just as heat is the collective motion of molecules, could space-time be the collective pattern of something even more basic? Could loops, strings, or networks give birth to the space you think you move through, and the time you think you move with? In loop quantum gravity, space is made of loops, tiny, discrete chunks, woven together like a cosmic chainmail. Space becomes quantized, not continuous, but digital. There's a smallest possible volume, a minimum area. You can't cut space infinitely thin. There is a Planck length, a quantum of distance, beneath which the very concept of here and there dissolves. Or maybe strings are the answer, vibrating one-dimensional filaments, whose oscillations give rise to all particles, forces, and even dimensions themselves. In string theory, gravity isn't a separate force, it's just one more vibration. And the geometry of space is determined by how those strings curl, twist, and resonate in invisible dimensions. But even string theory might be too generous. Some physicists go further. Maybe space and time aren't real at all. Maybe they emerge from entanglement, from pure information. Maybe what you call space is a map of relationships, not positions. Maybe time is just the changing of those relationships. The closer you get to the quantum realm, the more slippery everything becomes. At the Planck scale, space-time is thought to be foamy, a quantum froth, flickering with uncertainty, warping and collapsing and reforming every fraction of a second. Black holes, which seem to be the ultimate gravitational wells, now appear as paradox factories, places where information is trapped, burned, or duplicated depending on which theory you follow. The firewall paradox, the information paradox, the holographic principle law emerge when you try to merge quantum mechanics with gravity. And they all whisper the same thing: we don't yet know what reality is. But maybe quantum gravity holds the key. Maybe the granularity of spacetime is the missing piece, the bridge between the laws of the big and the laws of the small. If gravity can be quantized, then the universe is truly digital at its core. Not just the particles, but the space they inhabit. And that changes everything. It means the universe has a resolution limit. It means space isn't a computation. It means time doesn't flow, it updates. Reality isn't a stage, it's a process, and you, moving through it, are not a character on the screen, but part of the code itself. So what does it mean, then, to live inside a quantum world? Does it mean you are finite? Does it mean free will is just an emergent illusion from deterministic evolution of quantum states? Or does it mean something more poetic, that reality, like music, is not made of continuity, but rhythm, vibration, pattern? If space-time can be broken into pieces, can your mind, consciousness? Is there a Planck moment for awareness? Smallest unit of thought. Is the act of observing gravity itself a gravitational act? And if the background of the universe is built from something else entirely, then where are you standing? What are you standing on? You trust your senses to tell you that space exists, that there is here, and there is there. But if space is quantized, then your experience is a hallucination stitched together by averaging. You believe in flow, in continuity, in motion, but those might all be illusions. A high-resolution simulation emerging from something raw and more fractured. Quantum gravity is not just a scientific theory, it is a mirror, and it reflects a version of you that no longer stands on solid ground. A version of you that floats in an abstract network of probabilities, entanglements, and rules that cannot be seen or touched, only in. And when you stop pretending that space and time are given, you start seeing reality for what it might truly be, not a place, but a happening. Not a container, but a computation. Not a map, but a mystery. So the next time you step forward, remember you may not be moving through space at all. You may be collapsing it into existence, with every decision, every observation, every breath. And the question lingers, like the echo of a particle that never knew where it was. If space and time are made of something else, what are you made of? The quantum Cheshire cat, a particle's properties can exist. Without the particle, you've always thought that things belong to themselves, that a smile belongs to a face, that weight belongs to a body, that a thought belongs to a mind. You've moved through your days, certain that what you touch, what you feel, what you carry within you is tied tightly and immovably to the source it came from. Your voice echoes in a room, and you believe it began from your throat. Your shadow stretches on the sidewalk, and you assume it's just an outline, not a fragment. But what if the universe doesn't obey this loyalty? What if the very concept of ownership of traits belonging to things is a comforting illusion stitched together by your need for continuity? What if the very properties of something, its position, its momentum, its charge, its spin could wander off like ideas, leaving a poet behaving as if they existed, not within the object that birthed them, but beside it, around it, even far away from it? Imagine walking through a room and leaving your reflection behind, not in a mirror, but floating mid-air, untethered, suspended like a memory that hasn't yet decided to disappear. It mimics your expression. It curls with your last smirk, flickers with the residue of your most recent thought. And somehow, despite your absence, it remains hanging like punctuation at the end of a sentence that no longer has a speaker. Your body keeps moving, but some essence of you lingers where you were, like perfume in an empty room. That's not poetry. That's quantum mechanics. And deep within its strangest corners, among the particles that flicker between being and not being, lives one of its most haunting, most enchanting ideas. The quantum Cheshire cat. You've heard the name before, Cheshire cat, the grinning feline from Alice in Wonderland, who could vanish, leaving nothing but his smile behind. He was a joke, a riddle, a character of paradox. But physics, ever the collector of strange metaphors, borrowed that grin and gave it a laboratory. It asked, can a thing exist if it's not all in one place? Can something be separated from itself and still be real? And then, disturbingly, it found the answer might be yes. You were taught that particles are like tiny marbles or specks of matter, darting across the void, like well-behaved messengers of the physical world, each with its mass, spin, charge, position. But the quantum world doesn't offer you that comfort. In 2013, physicists crafted an experiment using that carry no charge, but plenty of mystery and ran them through a neutron interferometer. This device splits a quantum wave function into two paths, allowing different versions of a particle to explore different realities before being recombined. And what they found was unsettling. They detected the presence of the neutron in one arm of the interferometer, and its spinor fundamental property, like a particle's soul, in the other. The neutron went one way, its spin went another. The cat vanished, but the grin stayed. And you, a rational observer in a seemingly logical universe, are left blinking. What does this mean? What is identity if its pieces can travel separately? What does it mean to be a thing if your essence can fragment and still behave as if it belongs to something that's no longer present? It's not just a scientific curiosity, it's a mirror. And in it, you see the quiet fracture lines of your own assumptions. You've always thought you were whole, a body, carrying a mind, a voice echoing a thought, a name reflecting a self. But what if your mind and your breath and your choices could peel away from you, like skin from flame? What if your will could stay rooted in a place your feet have already left? What if your warmth could be remembered by a room long after your presence is gone, not metaphorically, but mechanically? The Cheshire cat experiment forces you to consider. Perhaps you are not a single, indivisible being. Perhaps you are already a collage, orchestra of attributes that sometimes play together, sometimes apart. And maybe this is why you feel scattered some days. Why your heart remembers what your body wants to forget. Why your thoughts race ahead of your voice. Maybe your sense of self is not one monolith, but a flickering constellation of fragments, each spinning, shifting, overlapping, but never completely anchored. And here's where the rabbit hole goes even deeper. In quantum mechanics, observation isn't passive. It's not watching, it's sculpting. When you observe a particle, you pull it out of its cloud of potentials. You force it to collapse, to decide, to show a face. To observe is to chisel possibility into presence. But what if your act of observing only pulls one property at a time? What if every observation you make is a choice about what part of reality you're allowed to bring into focus, and what parts must remain hidden? Maybe the universe doesn't tie traits to things. Maybe it only gives you conditional snapshots. What's true if you ask that question? And what's lost the moment you look away? So think about your own identity. You say, I am kind. But are you kind when no one needs kindness? You say, I am confident. But does that confidence exist in rooms where you are silent? Perhaps your traits, like spin, are measurable, but not fixed. Perhaps they arise only in relation to context, to attention, to the eyes of another. Could your courage live in someone else's memory, even when you feel afraid? Could your laughter still echo in a space you no longer enter? Quantum Cheshire cat behavior suggests that properties are not stored within things, but emerge between them, between what is asked and what is offered. The neutron's spin didn't belong to it, belonged to the question, and maybe your sense of identity is the same. Maybe yourself is not an object, but a dialogue between sensation and story, between presence and perception. Maybe your being is not a location, but a relationship. That might sound frightening, but it also means you are not trapped. If you are not a closed box of traits, then you are free to evolve. The labels you wear, failure, friend, misfit, genius, are not tattoos. They are measured properties, echoes of attention. They are outcomes of interactions, not definitions. If kindness can drift like spin, then so can shame. If joy can exist apart from memory, then so can pain. You are not frozen by what you've been. You are not your reflection. You are the possibility of coherence. The Cheshire cat teaches you to let go, to understand that coherence is a performance, not a promise. That identity is stitched together with threads of attention, narration, observation, and that the stitching can always change. You are not here to cling to your properties. You are here to learn how to recompose them, to shape your pattern again and again, so when you look around your life, your habits, your voice, in someone else's memory, ask yourself, what parts of me have wandered? What parts remain? What smiles have I left behind in rooms that no longer call my name? What warmth still lingers in the silence of another's thoughts? Maybe you are more than a thing. Maybe you are a pattern that keeps are not the cat or the grin, but the echo of their separation. A shimmer of identity, always between here and elsewhere. And so, the next time you feel lost, uncertain, fragmented, remember, it may not mean you are broken. It may mean you are in quantum motion. Your properties haven't abandoned you. They've just taken different paths for a while. Let them return. Or don't. Let them form new versions of you, versions, not tied to past definitions, but to present intentions. Because in a universe where a neutron can leave its spin behind, maybe you too can leave behind the traits that no longer serve you and keep only the grin that reminds the world you were here, even after you're gone. Time-symmetric quantum mechanics. What if time flows both ways? You've always imagined time as an arrow, clean, linear path, from past to future, from memory to hope, from what was to what might be. But what if that arrow could shatter into two, flowing in both directions at once, weaving the future into the past, like threads in a cosmic tapestry you can never fully see? What if time doesn't move forward, but simply is? A block of space-time where every moment, birth, laughter, loss, death already exists. Not unfolding but coexisting like pages in a book that your consciousness slowly flips through, believing it's writing the story as it goes. Picture yourself walking into a room, reaching for a glass of water. And somewhere unseen by you, your future hand is already pouring it. Already deciding the motion. Already realigning the past around the ripple you haven't even caused yet. This isn't fantasy. It's the foundation of time-symmetric quantum mechanics, a view of reality that doesn't just challenge your understanding of time, it bends it back on itself, like a Mobius strip, smooth and endless, where beginnings and endings blur into one another. In the microscopic world, the laws of physics don't care whether time flows forward or backward. A particle can move from point A to B, and the mathematics allows it to do just the opposite, with equal probability from B to A, like a conversation that echoes before it's spoken, or a decision that casts its shadow before your doubt even forms. You've been told cause leads to effect, that choice shapes outcome, that you are the author of your own timeline. But what if the ink is dry before you write, and the outcome chooses the cause just as much as the cause leads to it? In certain interpretations of quantum mechanics, particularly in experiments involving entangled particles or the delayed choice, quantum eraser, the future can appear to influence the past, as if the universe is less like a domino chain and more like a puzzle where every piece knows where the others must go. You collapse a wave function now, and somehow, something before that collapse seems to realign. How can you exist in a world where your observations sculpt not only what is, but what was? Could your gaze today shape yesterday's truth? Could your regrets echo backwards, folding into moments you thought were already gone? Rewriting the script while you still believe you're improvising. The symmetry of quantum laws doesn't guarantee that time flows both ways for you. But it does whisper that the universe itself doesn't distinguish between forward and back, it only sees the equation. You, however, live inside the illusion of direction. You experience entropy increasing, memories stacking, birthdays piling behind you like footprints fading in the snow. But those are markers of your perception, not evidence of the universe's allegiance to the forward march. We build clocks to tame time, but we don't ask why they should tick in just one direction. We record history as a sequence, but we don't consider that memory might be a filter rather than a truth. Perhaps time is not a river, but a dimension, and you're simply sliding along a line that was already there, mistaking movement for authorship. And what if the self, the part of you that says, I was, I am, I will be, is just a spotlight traveling across a frozen landscape of possibilities, lighting each moment in order and calling that order reality? There are physicists who suspect that the arrow of time may not be as sacred as we assumed, that the Big Bang may have sent time flowing outward in both directions. One toward our universe, one toward a mirror cosmos we can't access, where entropy decreases, where stars are unborn, where memories are premonitions. Could someone there feel as real as you, believing they too are headed forward, except their forward is your backward? If time symmetry holds, then every process you experience has a time-reversed twin. And your present might be a handshake between two eternities that never meet. It makes you wonder, do you choose your future, or does your future choose you? And in the spaces between choice and outcome, is there a hidden rhythm? A quantum beat pulsing both backward and forward, calling out from moments that haven't yet reached you but already know your name. What if every breath you take sends waves through time in both directions, one felt, one forgotten, one still waiting for you in a version of the past you never questioned? You were taught to ask, what happens next? But maybe the more honest question is, what's already happening, in both directions, that I simply haven't noticed yet? The future may not be a path you walk, toward it might be a mirror behind you, reflecting not just who you'll become, but who you've always been, refracted across time like light through a crystal. So if you ever feel something tugging at you from behind your own memories, a déjà vu that feels older than your thoughts, a strange certainty in a moment you've never lived, what if it's not coincidence, but echo? What if time isn't a road, but a reverberation? What if your life isn't a line, but a cordant? What you call now is just where the vibration happens to touch you. Maybe the universe doesn't unfold. Maybe it already is, and you, traveler of light, dreamer of clocks, writer of stories that were already written, are just learning how to read it backwards. But if that's true, then the real question isn't when you are, it's which way are you facing? Relational quantum mechanics, nothing exists independently. You've always believed the world exists, whether or not you look at it, that the moon is still there when your eyes are closed, that a tree falls, even if no one hears it, that reality is built from hard, fixed blocks of stuff, independent of your gaze. But what if that quiet assumption has always been a comforting lie? What if nothing truly is, unless something else is there to define it, like a face needing a mirror, or a word needing a reader? Imagine you're floating in a vast black sea, with no stars, no floor, no sound, no color, just you, suspended. How would you know if you were even moving? If up existed? If you existed, without anything to relate to, even your heartbeat might vanish into irrelevance. This is not a thought experiment, it's the foundation of one of the most radical and unsettling interpretations of quantum physics, relational quantum mechanics. In this view, nothing has meaning, position, or even reality in isolation. Objects don't possess properties on their own, they acquire them only in relation to something else. A particle doesn't have a location, it has a location relative to an observer. An atom doesn't have a spin, unless something is there to define its direction. You don't just exist, you exist in reference to others. Strip away the web of relations, and what remains isn't silence, it's undefined. Not emptiness, but meaninglessness. In classical physics, you could imagine the universe as a grand stage, with particles performing their parts, regardless of who's watching. But in the quantum world, the stage and the play don't appear until an audience enters. Not because observation creates reality, but because interaction does. Nothing plays solo. The cosmos is not a standalone sculpture, it's a shifting choreography, where the dancers only take form when they respond to each other. Think of light, it's both a wave and a particle, but not in a vacuum. It takes on one character or the other, depending on how you ask it to behave. In this view, truth is not absolute, it's conversational. And that's what relational quantum mechanics tells you. The universe isn't a monologue, it's a dialogue. Written in entanglement and measurement. There is no cosmic narrator reading a single script. Every observer writes their own version, and the plot unfolds differently for each. One system, many realities not parallel, but coexistent, relational. When you measure an electron, you don't reveal a hidden value, create a relationship. Before you intervened, there was no definite spin, no hidden truth waiting to be found. Just a cloud of possibilities collapsing into a shape that fits your question. Now ask this: what happens to the electron's spin in relation to another observer who didn't measure it? Their answer will differ, they'll live in a different reality, and both will be valid. Not because truth is slippery, but because reality is stitched into relation, not substance. This doesn't mean there's no reality. It means reality is like color, real, yet dependent. Red is real but only when there's an eye to see it, a light to reflect it, a context to compare it. Without these, red is undefined, not invisible. That's what the universe may be, not made of things, but of comparisons. And now think of you. You want to believe you are something in and of yourself, self-contained I, that can stand apart. But maybe that too is a fiction. Maybe you are not a noun, but a verb, a dynamic web of connections. You are not you alone, but you, in context, you as seen by others, felt by your family, remembered by a friend, misunderstood by a stranger, reflected in a lover's eyes. Strip all that away, who are you without relation? Could identity even exist without contrast, without interaction, without the mirror of another consciousness? Is love just a bond between two minds, or is it the very mechanism by which two selves are born through each other? In relational quantum mechanics, there's no universal state, only states between. No universal truth, only truths in exchange. And doesn't that echo your own emotional life? You are happy, but only in relation to your past sorrow. You feel lonely, but only when compared to moments of connection. You exist in flux, and your inner world is shaped not by constants, but by the collisions and harmonies of your experiences. In physics, as in life, relation defines reality. You don't float in a vacuum of certainty, you vibrate in a mesh of mutual definition. And this is where science touches the edge of philosophy. If nothing exists independently, then to exist at all is to be known, to be felt, to be in relation. The tree falling in the forest doesn't just need a witness to make a sound, it may need a witness to exist in the first place. The particle needs the observer. The thought needs the mind. The self needs the other. This is not mysticism, it's mathematics, and it doesn't say you are less real. It says your reality is more interwoven than you realized. So maybe the deeper truth isn't that everything is connected. Maybe it's that nothing exists without connection, not even time, not even mass, not even you. So what happens if you isolate yourself? Do you dissolve, little by little, into a blur of unmeasured potentials? Do you become less defined, less you, with every missed conversation, every avoided gaze, every moment you refuse to be seen, felt, understood? Could loneliness be not just emotional, but ontological, a soft erasure of your very being from the shared reality web that holds you? And if so, then maybe healing doesn't come from finding yourself, but from being found, from stepping into relation, from allowing others to define you, not as an intrusion, but as a creation. Maybe meaning isn't something you have, it's something you grow together. So next time you look at someone and wonder who they are, remember, that question reflects back on you. Because in asking, you both become more real. The universe isn't out there waiting to be understood. It's here, between us, waiting to be related. And if everything is relation, then maybe the most real thing you'll ever feel is the moment someone sees you, not because it reveals who you are, but because it creates who you are. So now ask yourself, if nothing exists independently, who are you when no one is watching? Delayed entanglement swapping, a connection made after the fact. You've been taught that the present follows the past, like a footstep follows a footprint. That one moment hands off the baton to the next, that causality flows forward like a river, carving through time, steady and irreversible. But what if reality doesn't care about your sense of sequence? What if the future can reach back and rewrite the story of the past, as if time itself were a canvas smeared with intentions not yet born? Imagine looking at two people who have never met, never touched, never seen each other, and then shaking hands with one of them later, and that handshake somehow goes back in time and forges a connection between them that was never there before. Imagine a choice you make now, today, reverberating backward into yesterday, stitching meaning into events that, until your intervention, were just unrelated fragments. This isn't a trick of language, it's a real quantum experiment. It's called delayed entanglement swapping, and it breaks everything you thought you knew about cause and effect. In the quantum world, particles can become entangled, a mysterious connection that allows their properties to remain interlinked, no matter how far apart they are. You measure one, and the other instantly knows, as if the universe conspires to keep them coordinated. But with delayed choice entanglement swapping, the entanglement itself can be created after the particles are gone, after they've been measured, after their fates have supposedly been sealed. That is, two particles that never interacted, that never shared a past, that never touched each other in space or time, can become entangled retroactively, their history rewritten by a decision made after they were observed. Picture this: two pairs of entangled photons are created. Call them A, B, and C, D. One photon from each pair, say B and C, is sent toward a device that can entangle them together. But here's the twist. The measurement that entangles B and C happens after the other two photons, A and D, have already been measured by observers who thought they were unconnected. And yet if B and C are entangled afterward, then A and D, which never interacted, behave as if they had been entangled all along. Your action in the present carves a bridge into the past, retrofitting to unrelated events with a hidden bond. It's like meeting two strangers at a party, and then years later deciding they were best friends all along, and watching photographs of them suddenly update to show shared memories that never actually happened but now must have. And here's the most disorienting part. From the point of view of quantum mechanics, this isn't magic, or paradox, or contradiction. It's perfectly valid math. The equations are agnostic about sequence. They don't demand a timeline. They ask only for consistency. The universe, it seems, does not enforce your narrative preferences. It allows the story to fold, twist, echo sometimes backward. And now you start to wonder, if the future can shape the past, then is the past ever truly finished? Is anything final, or are you always walking across a stage whose backdrop is being painted behind you even as it recedes? If a decision you haven't made yet can entangle moments already lived, then what does that say about memory, about regret, about fate? Could you be living inside a mosaic of delayed consequences, pieces that only reveal their design once you choose to look? Think about how you remember your own life. Do you really recall it as a chain of causes and effects? Or is it a constellation that feel meaningful only in hindsight, only once you've assigned a narrative? Only after something in the present casts a light backward and illuminates the path. Perhaps your deepest connections were not felt in the moment they began, but in the moments after, when something snapped into clarity, when you realized that someone who was once a stranger now feels like they were always part of your story. Could that be a kind of emotional entanglement? Swapping your heart, rewriting its own past. In this light, maybe love itself is a delayed connection, stitched into place by choices made in the future. Maybe meaning is something that ripens backwards. That doesn't exist when the event happens, but blooms years later, changing how you felt, how you lived, as if it were always true. The universe, in this quantum vision, is not a straight road. It's a web of threads that loop and reloop, a tapestry that gets embroidered even after it's been hung on the wall. And you, the traveler, think you're walking forward. But maybe you're stitching your own footprints as you go, weaving past and present into a fabric that's never quite done. What if your memories aren't just stories, but living structures subject to edits you haven't made yet? What if time is less like a river and more like a book, where the ending revises the beginning, where your last page writes your first line? Science tells you this isn't just metaphor. In the quantum world, cause can flow both ways, and history can be reframed by what you choose to measure. That doesn't mean the past isn't real, but it means its reality is relational, contingent, contextual. Your reality is co-authored by your actions, and some of those actions haven't happened yet. So how does this change the way you live? If your present can redefine your past, does that make you more free or less? Do you carry the weight of rewriting history with every step you take? Or is it liberating to know that what matters might still be in flux? That closure is not a boundary, but a choice. Maybe you're not trapped in what happened. Maybe you're always entangled with what's yet to happen, and that entanglement seeps backward, coloring your origin story with shades you've only just begun to see. Perhaps that's why some moments in life feel so eerie, like you've been here before, like this already mattered before it even began. It's not reincarnation, it's retrocausality. It's the future whispering to the past, I'm coming. Wait for me. And if you've ever felt that sense that something you didn't understand back then suddenly makes sense now, as if your understanding reached backward and completed the puzzle, maybe that's not just memory. Maybe it's quantum storytelling. Maybe the universe is less like a machine and more like a song. Notes reverberating across time, harmonizing not just forward, but back. And maybe you are a note, too, not a fixed point, but an interference pattern of who you were, who you are, and who you're still becoming. In such a universe, truth is not just discovered, it's constructed. Not arbitrarily, but relationally. Measurement, in this view, isn't passive observation. It's a creative act. It defines what was, by choosing what is. And so maybe the ultimate act of being alive isn't just reacting to what's given, but rewriting what's already been. Not because it wasn't real, but because it was waiting to become fully real through you. So now, ask yourself, if the future can reshape the past, if entanglement can arrive late, but still reach deep, then what connections in your life haven't yet been formed that might one day turn strangers into soulmates, accidents into inevitabilities, silence into meaning? What if your story hasn't happened yet, not just forward, but backward? What if right now, without knowing it, you're giving a hidden coherence to a past version of yourself who once felt lost, aimless, disconnected, and, by simply existing, by choosing, you are sending clarity across the timeline to them? What if the deepest comfort you'll ever give is to your own forgotten self? Quantum contextuality, the value of a measurement, depends on what you measure it with. You've always trusted in numbers, in outcomes, in measurements, as if the world were a box of answers, just waiting to be opened with the right question. As if truth were a constant waiting to be uncovered, no matter who's holding the ruler or when. But what if reality didn't behave like a passive subject at all? What if the answers you receive aren't just about what you measure, but how you measure, what else you're measuring, and what context surrounds your act of knowing? What if the world is not a menu of fixed items to be selected, but a shifting canvas that changes depending on where you stand, what you're holding, and what you've already decided to look for? This is the unsettling, brilliant, and almost mystical heart of quantum contextuality, a principle in quantum mechanics that says the value of a property isn't just sitting there waiting to be revealed. It depends on the other properties being measured alongside it. In other words, a particle's behavior is not just about the particle, it's about the whole experimental setup, about everything else you ask at the same time. And suddenly, reality becomes a hall of mirrors, not because it's fake, but because it's infinitely responsive. You think you're discovering what is, but you're shaping it in the act of asking. It's like walking into a gallery and realizing the paintings only take form depending on where you turn your eyes and what you looked at a second ago. A photon's path, an electron's spin, the color of an atom, they don't exist with intrinsic certainty. They crystallize in the context of other measurements, like musical notes that only make sense in a chord, or words whose meaning shifts in different sentences. The Kochen-Specker theorem proved this in the 1960s, that in quantum mechanics, it's impossible to assign fixed, pre-existing values to all properties of a system independent of the measurement context. Not because of ignorance, but because the universe doesn't allow it. Reality is fundamentally contextual, which means the truth you find is never the whole truth. It's the truth shaped by how you searched. And doesn't that feel eerily familiar? Haven't you noticed that the way you look at someone changes who they become to you? That the questions you ask in life change the shape of the answers you get, not just emotionally, but cognitively, neurologically. Your brain, too, is contextual. Memory isn't a recording, it's a reconstruction. And that reconstruction depends on your current mood, the stories you've told yourself since, what you're afraid to remember, what you need to believe. You aren't just experiencing reality. You're participating in it, creating it, but not freely contextually. And so, you live in a world where no value stands alone. Everything is colored by proximity. Everything is changed by what else is in the room. That's quantum contextuality. There is no isolated fact, only facts, in relation. Imagine holding a single puzzle piece. What is it? A green curve, a jagged edge. It's meaningless without the pieces around it. Only in context does it become sky, or leaf, or shadow. The same applies to you. You are not a fixed identity. You are a set of traits that only become real in context. You are funny when someone laughs, kind when someone needs, cruel when cornered, brave when the moment requires it. So who are you, really? Not a core but a constellation. Not a stone but a ripple. And now imagine that every person you've met has only ever seen one version of you, one measurement, shaped by their own context, their own questions. You've never been fully known. Not because you're hiding, but because you can't be extracted from your context. Neither can an electron. And the implications stretch even further. If reality is contextual, then objectivity is limited, not false, but bounded. Science becomes not a hunt for absolute truths, but a mapping of dependable responses. You ask, and the universe answers this way. In this setup, under these assumptions, change the lens, change the answer. There's no God's eye view. No all-knowing frame. There are only perspectives, and each one shapes the truth it perceives. But then, what does this mean for certainty, for morality, for meaning? Are you just a puppet of perspective, a fleeting echo of local variables? Or is this a liberation, an invitation to live relationally, To stop clinging to absolute selves and start dancing with the flux. Maybe freedom is not about having a core. Maybe it's about being fluid enough to reshape yourself with integrity. Aware that who you are depends on who you're with. What questions you're facing. What part of yourself you're asked to measure. Even ethics may be contextual, not relativistic, but responsive. Courage looks different in peace than in war. Honesty means one thing to a friend and another to a stranger. Just like a quantum particle, you are not dishonest or honest, you are both, depending on how and what is asked of you. You are Schrödinger's morality, undefined until measured, but always real, and so the mystery deepens. In a contextual universe, certainty becomes a spectrum. Knowledge becomes layered. And reality stops being a stone and starts being a poem, changing its rhythm with each voice that reads it aloud. Maybe that's what love is too, not finding someone who fits your expectations, but someone whose presence reshapes you in ways that feel true. Two people, two contexts, measuring each other, becoming real in relation. In quantum terms, they are not revealing each other's inner selves. They are creating shared truth. And maybe, if you've ever felt misunderstood, it wasn't that you were misread, it's that the context was incomplete. You were measured in the wrong basis, so the value came out distorted. You weren't seen as you were seen as you appeared in that moment, under those assumptions. But you can't blame them. You do the same, we all do. There is no omniscient observer. There is only you and me, and the questions we dare to ask each other. And what collapses into clarity as a result. And perhaps that's what makes existence so unbearably beautiful, that there is no one you, only a spectrum of potentials, blooming into form with each interaction. You're a poem written in shared languages. A particle that never settles into just one truth. So now, ask yourself, what truths have you taken for granted that might only be true in the light you've chosen to shine? What selves have you left in shadow because the context was never right to call them forth? And what if the deepest truths in your life, the ones you've doubted, the ones you've buried, the ones that never quite made sense, are still waiting for the right measurement, the right moment, the right you, to finally come alive? Decoherence versus collapse. What really ends superposition? You've been taught that things happen in sequence, that a coin flips and lands, that a choice is made and its consequences unfold, that reality moves from uncertainty into clarity with each passing moment. But what if that transition from possibility to actuality isn't so clean, so honest, or so final? What if every moment of decision, every collapse of uncertainty into a single truth, hides behind it a deeper ambiguity, one that never truly resolves, only appears to, because your perception demands it? Welcome to the mystery at the heart of quantum mechanics. Superposition, the idea that a system, like a particle, or a cat, or a universe, can exist in multiple states at once until observed. And at the center of this puzzle stands a haunting question. What actually ends superposition? What makes the wavefunction collapse into one outcome over another? Is it your act of observation? Or is it something more subtle, more environmental, more mechanical, like decoherence, the quiet bleeding of quantum states into the classical world, as fragile entanglements dissolve under the weight of context? You've likely heard of Schrödinger's cat, alive and dead in a box, simultaneously, until someone opens the lid. But you rarely ask, what opens the lid, really? Is it the human mind? Consciousness? Or does the universe quietly choose its path before you even arrive? Driven by the irreversible spread of information into the environment, the particles in the air, the photons bouncing off the walls, the invisible whisper of entropy spreading outward like ink in water, that's decoherence. It doesn't destroy superposition, it diffuses it. It spreads the coherence of a quantum system across so many degrees of freedom that the original pattern becomes unreadable. Like a melody drowned out by 1,000 overlapping echoes, the system hasn't chosen, it's been diluted. And yet, to your classical ears, that dilution feels like choice. It feels like outcome. It feels like collapse. But is it? Or are you simply blind to the ongoing symphony that continues in the quantum registers beneath your perception? In traditional quantum mechanics, collapse is abrupt, discontinuous, and final. The wavefunction, a mathematical entity that encodes all possible states of a system, suddenly jumps into one specific state when measured. But collapse, as a physical process, has no mechanism. It is postulated inserted into the theory without explanation, a necessary artifice to account for your singular experience of reality. Decoherence, on the other hand, offers a smoother narrative. No jumps, no mysteries. Just interaction and entanglement with the environment, leading to apparent classicality. It explains why you never see a chair in two places at once, why your cat is either asleep or alert, why the world appears sharp even if the math insists it shouldn't. But decoherence doesn't actually select an outcome, it only explains why alternatives become inaccessible. It doesn't say this happened. It says the rest became undetectable. So which is it? Is reality the result of collapsedon, fundamental, irreversible? Or is it an illusion born of decoherence, a kind of quantum forgetting, where all paths still exist but are hidden from you by the limits of observation? And more hauntingly, what role do you play in this unraveling? Are you the observer who triggers the end of ambiguity? Or are you simply another part of the environment, another variable in the grand entanglement, another passive agent swept along by entropy's flow? The truth is, no one knows. But in the debate between decoherence and collapse, what's really at stake is not just a technicality, it's the nature of existence itself. It's the question of whether reality is fundamentally determinable, or deterministic, whether outcomes are selected or simply revealed. And in that uncertainty lies a mirror to your own life. How often have you felt caught between possibilities, between versions of yourself that could be, between lives you almost lived, and when you finally choose, when the you of this timeline solidifies, what happened to the others? Were they illusions, discarded, forgotten, or do they echo on in hidden dimensions of identity you'll never access again? Is your personality a wave function? Is your sense of self the outcome of an unobserved collapse? When you make a decision, is that the end of superposition or the beginning of decoherence? As consequences ripple out into the world, entangling others, until no one remembers the alternatives. Maybe your life doesn't collapse at each moment. Maybe it spreads, decoheres until your potential becomes so scattered that only one path remains coherent enough to recognize. And what if that means you never truly choose, you simply drift toward what remains visible? Is that freedom? Or is it inevitability, wearing the mask of agency? Perhaps collapse is a comforting idea that gives closure to a process that may never truly close. But perhaps decoherence is more honest. The acknowledgement that certainty is local, temporary, and partial. That clarity is a trick of perspective. That reality never narrows, it just appears to, because you can no longer perceive the breadth. And this reframes how you think about responsibility. If your actions entangle with the environment, if your choices ripple and lose coherence in a sea of interactions, then maybe the clean lines of blame and intention were never as firm as they seemed. Maybe the you who made that mistake is already dissolved, unreachable, part of an entropic field that no longer reflects your current shape. Maybe redemption is not about collapse, but about recollecting coherence, about finding enough clarity to realign, enough stillness to remeasure. In the lab, experiments continue. Some physicists cling to collapse, others to decoherence, some to many worlds, some to hidden variables. Each trying to answer the same aching question: how does the potential become the actual? But beneath their equations lies a human longing, the need to believe that the world is, not just might be. That our stories, our choices, our love and loss, are real, not smeared possibilities, not vanishing amplitudes. And yet, maybe that's what makes them so precious, that they could have been otherwise. That somewhere, deep in the quantum substrate, your life was once a superposition of joy and sorrow, courage and fear, silence and confession, and what you call you is the strand that Descartes just enough to be heard. So now, standing at this crossroads of physics and self, ask not what ends superposition in the labette, what ends it in you. When does your potential become your truth? When does the blur become a choice? And is that moment sudden like a collapse, or slow like forgetting? Are you defined by what you measure or by what you've let fade into the background? Maybe you'll never find the answer in equations. Maybe the answer was always in how you remember who you could have been. Quantum causal loops. When effect can precede cause. You've always believed in sequence, that moments follow each other like beads on a thread. That time is an arrow, neat and disciplined, always moving forward from cause to effect, from ignition to explosion, from breath to word to echo. But what if that thread could tangle, loop, fold into itself? What if the arrow could twist in mid-air, strike the target before it was fired, leaving you standing in the ruins of something you haven't yet done? You've accepted that the past shapes the present, and the present shapes the future, but quantum mechanics, with its ghostly mathematics and paradoxical logic, whispers something far stranger: that the effect can come before the cause, that the answer can precede the question, that what you do tomorrow might already be changing who you are today. This is the disorienting, yet rigorously explored world of quantum causal loops, where the timeline doesn't always flow like a river, but behaves like a whirlpool where events can circle back, where a decision made in the future can close a loop that began in the past, as if the universe itself is not linear, but recursive. You think of causality as a chain, but what if it's a circuit? In certain quantum scenarios, especially those involving entangled particles, delayed choice experiments, and post-selected measurements, events don't simply lead from A to B. Sometimes B must exist in order for A to occur at all. And yet, both are real. Both are observed. It's not that one causes the other, it's that both define each other in a timeless handshake. A mutual agreement that reaches across the span of what you thought was time. Think of a telephone ringing, and only then deciding to dial the number. Think of waking up crying from a dream, only to discover later that the person you wept for was just then calling your name in their own room. Across the house, across the world. It sounds like fiction, but quantum causal loops are not invented. They are mathematically consistent, experimentally considered, and philosophically devastating. In a framework known as the process matrix formalism, developed by quantum theorists like Václav, Bruckner and others, the very notion of a fixed causal order breaks down. In this model, it is possible to construct scenarios in which no event is definitively before or after the other, and yet probabilities still behave sensibly. Logic remains intact, even if time does not. You might ask, how is that possible? How can something be the cause and the effect? How can the fire light the match? But in quantum mechanics, the timeline is not as sacred as you want it to be. There are situations where measurements and their outcomes seem to retroactively determine each other, where your choice to observe something in the present defines its state in the past. And though the information never travels faster than light, causality in the traditional sense remains unbroken. The very meaning of before and after becomes blurry, conditional, observer-dependent. And now, it's no longer just about particles. Now it's about you. How many moments in your life have felt like echoes from a future you haven't reached yet? A sudden knowing. A decision you couldn't explain. A meeting that felt scripted. A regret for something that hadn't yet gone wrong. What if your intuition, your déjà vu, your strange pull toward certain paths, is not imagination, but resonance across the loop? What if time is not a hallway, but a spiral staircase, and some part of you is already higher up, looking back? You wouldn't notice. You would call it instinct. But maybe it's feedback from the self you haven't met yet. Maybe it's the afterimage of a choice you will make, one that will loop back and rewrite your sense of now. In classical physics, loops are forbidden. They invite paradoxes, like the grandfather paradox, go back in time and prevent your own birth. But quantum loops operate differently. They don't erase themselves, they entangle. They interlock. They form closed timelines that remain logically self-consistent. It's not this or that. It's this because that, because this. And your mind struggles, because you've always relied on time to make sense of identity. I was that, now I'm this, soon I'll be something else. But what if the you become defines the you were? What if becoming someone brave in the future sends ripples backward, lending strength to your younger self? What if choosing to forgive tomorrow makes your past feel lighter today? And what if guilt, shame, or love doesn't travel only forward, but echoes back through the corridors of your memory, reshaping your understanding of who you've been? Perhaps you're not only a product of your past, but the architect of it. Not literally, not through time travel, but through something deeper. Interpretation. Quantum causal loops remind you that interpretation is reality. That what something means is not set when it happens, but when you close the loop. You can't always understand a moment while you're in it. Sometimes it only makes sense years later. But when it does, the past transforms. The story is rewritten. Not factually, but existentially. A wound becomes a lesson. A silence becomes a kindness. A goodbye becomes a beginning. And in that way you cause your own past to become meaningful. You cause healing backward, and doesn't that feel like magic? But it's not magic, it's coherence. In physics, coherence is the condition that keeps quantum systems from collapsing. It's the alignment that keeps superpositions intact. And perhaps your psyche has coherence, too, a continuity not just of memory, but of meaning. Your life is a quantum system, looping and entangling, rewriting and completing itself, not through perfect logic, but through recursive insight. You heal by closing loops. You grow by reaching back. So maybe the most important causes in your life are effects you haven't yet experienced. Maybe your future choices are already guiding you. Not because time is fake, but because time is more flexible than you dreamed. And if that's true, then every moment matters, not just as something you endure, but as something you will one day understand into truth. Not every pain is its own reason. Sometimes, the reason comes after, and when it does, it travels back and redeems the pain. That's the loop, that's the gift. So now, ask yourself, what part of your past still feels incomplete, still open, still echoing? And what if the answer isn't behind you, but ahead, waiting for the loop to close? The page curve and black hole information paradox. You've always assumed that when something is lost, it's gone, that fire consumes paper, that endings are absolute, that information, like breath in the cold, vanishes into the void once it slips beyond your grasp. But what if the universe doesn't forget? What if nothing is ever truly lost, even when it's pulled into the most silent, crushing depths imaginable? What if every scream, every secret, every spark of light that falls into a black hole still exists, somehow encoded into the skin of space-time, waiting to be decoded long after the fall? This isn't wishful thinking. It's the foundation of one of the deepest puzzles in modern physics. The black hole information paradox. A paradox born from a clash between two titans: quantum mechanics, which insists that information is never destroyed, and general relativity, which suggests that when something crosses a black hole's event horizon, it's gone for good. At the center of this storm is something called the page curve, deceptively simple graph that holds within it one of the most profound existential questions science has ever asked. Does the universe remember everything, even what you thought it forgot? To understand the weight of that question, you must first imagine a black hole, not as a monster, but as a storyteller, a place where matter collapses into gravity's rawest form, where time stretches and breaks, where light forgets how to leave. When Hawking first proposed that black holes emit radiation now called Hawking radiation, it changed everything. It meant black holes can evaporate, they can shrink, they can disappear. But this created a terrifying implication. As they vanish, so does the information about everything they ever consumed. Gone. Not scrambled, not hidden, erased. But in quantum mechanics, this is forbidden. Information must always be preserved. It can be transformed, entangled, disguised, but never destroyed. To do so would tear the fabric of the quantum world itself. So how could both theories be right? Enter the page curve. Proposed by physicist Don Page, it attempts to answer how black holes might evaporate while still preserving information. In the early stages of evaporation, the entropy, the measure of disorder or information loss, increases, as expected. But halfway through, something strange is predicted to happen. The entropy begins to decrease. This suggests that the radiation itself begins to carry information outward. Somehow, what falls in is gradually encoded into what escapes. The black hole becomes not a tomb, but a translator. Not a grave, but a mirror. And suddenly, you're not just thinking about physics anymore. You're thinking about yourself. How many things have you tried to forget? Moments you buried, feelings you locked away, choices you made and cast into the darkness of memory. And how often have those moments returned not as they were, but reformed, scattered across the surface of your present like radiation? What if you are your own black hole, consuming experiences without knowing where they go? Only to discover that they never vanished at all, they were merely waiting to be decoded in new forms. In dreams, in habits, in fears, in echoes. Maybe grief is Hawking radiation information, escaping the collapse of something you couldn't hold on to. Maybe healing is the page curve, the slow recovery of what was lost, the rise and fall of emotional entropy. The paradox, then, is not just cosmological, it's psychological. Can you truly lose part of yourself? Or does it all remain, imprinted somewhere deep, waiting for time and pressure and experience to push it back out? And what happens when a black hole finishes evaporating? If information survives, it must go somewhere, but where? On the event horizon itself, as some physicists suggest. In the radiation? In a baby universe? Or does it emerge in ways we don't yet understand non-locally? Fractally whispering that our assumptions about space and time are simply too crude to contain what reality actually is. One of the most powerful ideas to arise from this puzzle is the holographic principle, that everything inside a volume of space can be described by information encoded on its boundary. Not unlike your memories, which seem to live inside your brain, but are shaped and accessed only at its edges through sensation, emotion, perception. You don't remember from the core, you remember from the surface. You reconstruct, you rebuild, you project, and maybe the universe does too. The page curve, if correct, means that the story of what was swallowed isn't over, it's just being rewritten, bit by bit. Radiated into the world in strange new languages. And maybe that's what you're doing with your own past, releasing it, slowly, painfully, beautifully, through the things you say, the art you make, the people you love. Maybe your scars are information escaping from collapsed versions of you. And now the question becomes, can you ever truly let go of anything? Or does everything you experience get woven into the horizon of your identity, irreversibly entangled with who you are, no matter how deeply you try to bury it? If black holes don't forget, do you? Perhaps the real paradox isn't whether the universe preserves information. Perhaps it's whether you can bear to know that you do too. And if so, then everything matters. Every word, every silence, every moment that felt like it disappeared into nothing. They don't vanish, they transform. And the shape of that transformation might be written not in straight lines, but in curves, in the shape of entropy over time, in the curve of pain, turning into meaning. That's the page curve. That's the quiet proof that even the darkest, most final seeming collapses are not the end of the story. They are a transition point. They are entropy's crest before the recovery begins. So if you're standing at the edge of your own collapse, something inside you has fallen past the point of no return. Assume it's over. Don't believe the light is gone. Watch closely. Wait. What feels like annihilation may be the beginning of information, finding its way back to you. And perhaps, just perhaps, the universe is watching too, measuring not whether you fall, but how you return. So ask yourself, what has your gravity consumed? And what parts of you are still escaping, photon by photon, story by story, into a world that might yet remember? Bohmian mechanics, the pilot wave hidden beneath reality. You've always believed that particles move like bullets through space, that the world is made of tiny, discrete pieces bouncing off each other in predictable or probabilistic ways, and that randomness is a feature of reality, not a symptom of your limited perception. You've learned that quantum particles don't have definite positions until you measure them, that they are clouds of probability, that the universe, at its core, is hazy, indeterminate, uncertain, and yet something inside you has always resisted this. Not because it's wrong, but because it feels incomplete, like a symphony that ends on a dissonant note, unresolved. What if, hidden beneath the randomness of the quantum world, there is a deeper order? What if particles are not merely rolling dice in the void, but are being gently steered by an invisible hand, guided not by probability alone, but by something more elegant, more silent, more exact? This is the radical poetic heart of Bohmian mechanics, also known as the pilot wave theory. A lesser known but breathtakingly beautiful interpretation of quantum mechanics that dares to say, what if everything is guided? Not predicted, not predetermined, but guided, as if each particle, including you, were riding the crest of a wave that knows where it's going, even if you don't. In Bohmian mechanics, particles have precise positions at all times. They are not fuzzy, they are not smeared across possibilities. They move in definite trajectories, but their motion is not random. It is choreographed by a pilot wave, a mathematical entity derived from Schrödinger's wavefunction that evolves deterministically and steers the particle like a riverbank, shaping the path of water. You can't see the wave, but it shapes everything. And suddenly, the universe becomes a duet. Particles and waves, matter and meaning, reality and hidden guidance. It's a theory that restores clarity without killing mystery. And now you begin to wonder, what if your own life has a pilot wave? What if your decisions, your thoughts, your seemingly spontaneous moments are being quietly influenced, not controlled, but nudged by something deeper than will, something older than mind? Not fate, not destiny, but a structure beneath your chaos, a current beneath your surface. Bohmian mechanics tells you that even in the heart of what we call random, there may be subtle order, an invisible geometry that gives shape to motion without revealing itself directly. In the double-slit experiment, where a single particle seems to interfere with itself, Bohm's interpretation offers a stunning clarity. The particle always goes through one slit. But its pilot wave goes through both, and it is this wave that guides the particle to its final destination. There's no mystery, no collapse, just unseen guidance. Just the choreography of a wave you'll never touch, but always feel. And doesn't that echo something in your soul? That sense that your life has patterns you can't quite explain. That you are drawn to certain places, people, ideas, not by chance, but by some intangible pull. Maybe your choices were always your own, but maybe they followed a terrain you couldn't see. Like a hiker walking across a dark landscape. Your path looks random until you glimpse it from above, and then the trails, the ridges, the rivers, all make sense. Bohm believed that this hidden order could unite the world of particles with the world of experience. That instead of seeing the wave function as a probability with a catalogue of potential outcomes, we should see it as a real field, a physical guide, a container of form, and that means we're not living in a fragmented universe of chance and collapse, but in a holistic reality where everything is connected through this underlying field. Where the universe doesn't wait to be measured, but knows where it is and where it's going. But Bohm's vision goes further. He didn't stop at physics. He saw this hidden order, the implicate order, as he called it, as a universal principle. Not just for particles, but for consciousness, for meaning, for life itself, he imagined. A reality where the visible is just the unfolding of the invisible. Where what you see is the shadow of something more whole, more complete, more deeply real. In this view, your thoughts, your emotions, your sense of time, are not isolated phenomena. They are expressions of a deeper wave. And if that's true, then maybe your anxiety is not just chemical. Maybe your longing is not just psychological. Maybe they are signals, resonances from a deeper field trying to steer you back into coherence. Maybe you are not broken. Maybe you are entangled. And maybe healing is not about forcing change, but about tuning into the guidance already present, already flowing beneath your confusion. So how does this interpretation differ from standard quantum mechanics? In one way it doesn't. The predictions are the same. The math is compatible. But the philosophy is different. The story is different. One says, things happen randomly and only become real when observed. The other says, things always happen, always exist, always move, but according to a wave you cannot see. And now you have to ask, which story feels more real to you? Which one resonates with your experience, not just of physics, but of being? You've had moments, haven't you? Where everything clicked, where life moved with grace, where the world seemed to open up and show you a hidden path, and you've had moments of noise, confusion, fragmentation. Maybe those weren't random. Maybe you were out of phase with your pilot wave. Maybe your deepest clarity comes not from thought, but from alignment. Bohmian mechanics tells you that reality is not fundamentally chaotic. It is not indifferent. It is structured, layered, guided. And even though you can't see the pilot wave, you are never outside of it. You are part of it. And if you're part of it, then you are not separate from the world. You are not alone in a sea of randomness. You are inside a flow, a process, a living wave that holds your past, your present, and all your potential futures within its form. That doesn't mean you're controlled. It means you are carried. It means you move in harmony with something deeper than intellect. And perhaps your most important work is not to control, but to listen, not to predict, but to align. So now ask yourself, what is guiding you? What wave are you riding? What force moves beneath your feet, your thoughts, your breath? And if you could feel it, if you could truly attune to the pilot wave of your own existence, where would it lead you? Quantum phase transitions, matter changing without heat. You've always associated change with heat, with friction, combustion, pressure, like something must break, or boil or burn, in order to become something else, as if transformation is always violent, always visible, always thermal. But what if matter could change its entire identity in absolute silence, at the coldest edge of the universe, without a flicker of heat or flame? What if reality could shift not because of temperature, but because of quantum alignment, a deeper rearrangement invisible to classical senses? This is the haunting beauty of quantum phase transitions, where the fabric of matter reconfigures. Not through fire, but through fundamental shifts in quantum states. Governed not by energy input, but by parameters like magnetic fields, pressure, or particle interaction strength. These are not transitions of temperature, they are transitions of being. They happen at absolute zero, where thermal motion ceases, and only the quantum soul of matter remains trembling, adjusting, transforming. And when they do, they reveal a truth so elegant it borders on mystical. That change does not always require chaos. Sometimes, change is the result of coherence, of tuning, of silent synchronization beneath the noise. In your world, you watch water boil, metal melt, air freeze, see that matter transforms when heat disturbs it. These are classical phase transitions. But deep beneath those transitions lies another layer of reality, one that doesn't wait for heat, one that changes. When the symphony of quantum states realigns. In a quantum phase transition, a system changes its ground state. The most fundamental configuration it can occupy it, by absorbing energy, but by evolving as a control parameter shifts. And this evolution is not smooth, it's abrupt. It's a cliff hidden in the fog. One moment, the system is in one phase. The next, it's in another. A magnet becomes non-magnetic. A superconductor appears from a sea of ordinary electrons. An insulator transforms into a conductor, but nothing has melted, boiled, or burned. The change is internal, deep, unseen. And doesn't that mirror something in you? Haven't you changed radically, utterly without making a sound? Haven't you woken up one morning and realized you no longer love who you once did? Or believe what you once swore by, or fear what used to paralyze you? No one saw the temperature rise. No one noticed the surface flicker. But something shifted. A phase transition. A self rearranged at the quantum level. Perhaps you are not as continuous as you appear. Perhaps identity, like matter, can exist in phases, and sometimes, you stand at the edge of your own internal critical point, where a small shift in environment, a subtle interaction, a whisper of pressure is enough to transform your most stable self into something unrecognizable. In quantum physics, this point is called a quantum critical point, and it is not a singularity. It is a nexus, a place where the usual rules blur, where fluctuations dominate, where correlations stretch across space and time. It is a region where the present reaches backward and forward, where particles speak across infinite distances, where systems are on the verge of becoming something else. Every atom knows it. These critical points are strange. They generate new kinds of order, new states of matter, even new particles. And they exist in the most pristine cold imaginable, not because they are frozen, but because they are pure. Pure quantum being. And in those conditions, the universe reveals its secret. That phase is not about form, it is about relation. A phase is how things relate, how they spin, how they entangle, how they move in concert. When those relationships shift, reality changes. And so do you. Your phases are not defined by your appearance. They are defined by your alignments. What you attune to, what you resonate with, what patterns you sustain. When you enter a new phase, you don't always feel it at first. The change is subtle, then sudden. A shift in how you think, how you respond, how you organize memory and emotion. You become someone else, not because of heat or violence, but because the invisible conditions reached a threshold, a quantum criticality of the soul. And just as matter can flip into superconductivity where resistance vanishes, where current flows eternally, you too can reach phases where your resistance drops, where your energy flows freely through the world. States of grace, moments of synchronicity, love that defies entropy, creativity that won't decay. And then there are insulating phases, moments where you disconnect, where emotion cannot pass, where no light enters. These two are phases, not lesser, just different, but always reversible, always sensitive to the field around you. And maybe that's the most beautiful and terrifying truth quantum phase transitions offer. That identity is fragile, that coherence is dynamic, that you are always near a boundary you cannot see. One conversation, one idea, one loss, one realization. That's all it takes to trigger a new phase. But you won't burn, you won't scream. The surface might remain still, and yet everything will have changed. And the question becomes, can you feel it when it happens? Can you sense the shift in temperature, but in tone, in rhythm, in meaning? Quantum systems, approaching a critical point, behave strangely. They slow down. They become hypersensitive. Their correlations stretch. Perhaps this happens to you too. Before transformation, you pause, you reflect, you feel more. Everything matters, everything aches. It is your quantum critical region, the space before the leap. And then new order. A new phase, but not always better, just different. Quantum phase transitions don't promise improvement. They promise difference. They promise that under new conditions, new selves emerge. So maybe growth is not always expansion. Maybe it's alignment. Maybe you don't become more, you become other. And you can't go back. Not because you don't want to, but because the system can't sustain the old ground state. It doesn't exist anymore. And that's not tragedy, that's evolution. So now, imagine yourself as a quantum system. You have a Hamiltonian, a set of governing energies. You have a wave function, your potentialities. And you have control parameters, your environment, your relationships, your thoughts. As those shift, so do you. Not smoothly, not linear, but through leaps, through transitions, through collapses into new phases. And just as physicists map the phase diagrams of matter, perhaps your life could be mapped. Too, not in dates or goals, but in states. The magnetic child, the conductive dreamer, the insulating adult, the superconducting artist, the glassy, entangled, incoherent survivor. And each phase is real. Each phase has structure. Each phase has its own laws. And none of them are final. You are never finished. You are a system on the edge of transformation, always. Not because you are unstable, but because you are quantum. Because even in your stillest, coldest moments, something in you is always ready to shift. And so you walk through your life not as a solid, fixed identity, but as a field of phases, some active, some dormant, some waiting for the right condition to emerge. And when they do, it will not be loud, it will not be fiery, but it will be real, and it will change everything. So now ask yourself, what phase are you in? And what quiet, invisible shift is already preparing the next? Quantum discord, a milder form of entanglement. You didn't know existed. You've always imagined connection as something binary. Either you're entangled, or you're not. Either you're joined, or you're alone. Either a particle is in superposition with another, or it's collapsed into separateness. But what if reality allowed for something softer? Something stranger? Something that lies in between intimacy and independence? What if two things could be connected, not through perfect harmony, but through quiet tension, a subtle, lingering misalignment that doesn't destroy the bond, but gives it weight, like a stretched string, still humming with shared vibration? You've heard of quantum entanglement. The eerie phenomenon where two particles become so deeply linked that the state of one instantly determines the state of the other, no matter the distance between them. But what if there's a shadow of that intimacy, an imperfect, lesser-known cousin that still binds particles with threads of influence, even when full entanglement has vanished? This is the realm of quantum discord, measure of quantum correlation, that persists, even when traditional entanglement is gone. It is the echo of connection, the afterimage of unity, the reminder that even in systems that appear unentangled, there can still exist a memory of togetherness, a trace of quantum coherence that hasn't entirely let go. And suddenly, it's not just a physical concept, it's emotional, existential, because you've known this feeling too, haven't you? That someone can no longer be part of your life, and yet they still shape it. That a relationship can fracture, but its geometry remains. That not all distances are absolute. Sometimes, what was shared lingers not as a presence, but as a distortion, a discord, not silence, but unresolvable resonance. In physics, discord reveals itself when the total correlations between two quantum systems exceed the classical part alone, even when there is no entanglement left. It means that measuring one system still disturbs the other, that the whole still knows it was once whole, even if its parts no longer sing in perfect unison. It is an asymmetry in knowledge, a non-classical residue of mutual awareness, and maybe that's what you carry in yourself, in the aftermath of love or loss. Not pure connection, but its ghost. Not classical memory, but quantum discord. You cannot simply unentangle from someone. The connection doesn't vanish when you stop speaking. It transforms. It lingers in the way your thoughts shift when their name is mentioned, in the way your language was shaped by shared vocabulary, in the way your dreams still reference a face that isn't there. That's discord. That's quantum history, bleeding into the now. Discord tells us that classical information isn't enough to describe the full content of a quantum system. There's something extra subtle, quiet, but real, and it can't be accessed directly. It's not something you observe. It's something you infer, something you sense by the way things don't quite behave as they should. It's not the sound, it's the interference pattern in the silence. In the lab, discord can be calculated from the difference between two forms of mutual information, one based on classical assumptions, the other on quantum reality. The gap between them is discord. And perhaps your life is full of such gaps, places where classical explanation falls short, where logic cannot bridge what only experience can sense. You can explain a friendship ending, but not why their absence still pulls at you. You can explain a memory's timeline, but not why it reactivates at midnight without reason. You can explain why someone's gone, but not why your body still flinches when you hear their voice on a stranger. There's no classical answer, only discord. And now you begin to wonder, is discord a weakness or a deeper kind of truth? Entanglement feels clean, absolute, almost romantic. But discord is messier, more human. It's what remains when perfection breaks. It's the thread that doesn't snap, even when the fabric tears. And isn't that how most of your relationships really are? Not quantum telepathy, but quantum friction. A subtle influence, a non-zero correlation, even when the systems claim independence. And here's the most radical insight. Discord isn't always a flaw. In some cases, it's a resource. Recent studies suggest that quantum discord can be harnessed for computational advantage, for information processing, for extracting work. Even in systems where entanglement is gone, discord still enables magic. It still enables function. It still means something. And so perhaps in your own life, what you've considered broken, what you've called a failed relationship, a faded bond, a closed chapter, still contains potential. Still contains informational power. Still affects outcomes. Just because something isn't fully entangled, doesn't mean it's irrelevant. Some of your greatest growth may come not from clean connections, but from persistent tensions, from unsolved harmonics, from learning how to operate within discord, not in spite of it. And now, consider this: discord is not symmetric. Measuring System A might disturb System B more than vice versa. The asymmetry is baked into the quantum fabric. And doesn't that resonate with how connection feels in real life? One person feels more, one person holds on longer. One person dreams, while the other forgets. One is disturbed by the bond's ghost. The other walks away, untouched. Discord allows for that asymmetry. It models the discomfort of unbalanced ties. And it validates that imbalance as something real, not a flaw in your character, but a feature of entangled systems navigating separation. You are allowed to feel more than they do. You are allowed to change while they remain still. The system is still correlated. The discord is still alive. And so perhaps the goal is not to eliminate discord, but to learn its language. To listen for what remains unsaid in broken bonds. To understand that even in your most fragmented relationships, something persists, something hidden, something that can't be measured with instruments, but only with awareness. Bohm called it the implicate order, the idea that everything unfolds from an underlying wholeness, even when it appears divided. Discord is one of its signatures, and maybe the way you heal is not by pretending the past didn't happen, but by acknowledging the discord it left behind, by integrating it, by transforming it. Just as quantum discord enables computation in the absence of entanglement, maybe emotional discord enables wisdom in the absence of peace. Maybe what you feel is not noise, it's signal, it's instruction. It's the guidance system left behind by an unfinished connection. So now ask yourself not, who are you entangled with, but who are you in discord with? Not who understands you perfectly, but who shaped you by not understanding you. Not what did you lose, but what remains, vibrating softly beneath your new identity. Changing the shape of your reactions, your choices, your story. Quantum discord is not the main character. It's the subplot you didn't notice until the end. It's the unresolved chord that makes the symphony feel real. And if reality contains such gentle asymmetries, such imperfect but persistent correlations, then maybe so do you. And maybe that's not something to erase. Maybe it's something to cherish. Symmetry breaking at the quantum level, where identity begins. You've always imagined that identity arises from complexity, that who you are emerges from years of memory, choice, pain, joy, experience, stacking on experience like bricks forming a cathedral of selfhood. But what if the root of identity lies deeper than you ever thought? Beneath neurons and thought, beneath biology and language, beneath even matter as you know it. What if the very concept of being something as opposed to nothing, as opposed to everything begins, not with decision, but with symmetry breaking? A moment in the quantum world where perfect balance surrenders to difference, where possibility fractures into particularity, where the universe ceases to be anonymous and begins to become recognizable. You've been told that symmetry is beauty, that symmetry is elegance, and indeed, in physics, symmetry is law. It governs conservation, guides forces, defines particles. A perfectly symmetrical state is uniform, indistinct, full of potential but devoid of uniqueness. In a symmetric system, every direction is the same, every configuration interchangeable, everything reversible. But the world you inhabit is not perfectly symmetrical. Something broke it. Something collapsed, the sameness. And in that collapse, identity began. In the quantum world, this isn't metaphor, it's structure. Symmetry breaking is not a glitch. It is the origin of form. When the Higgs field gave mass to particles, it did so not by uniformly coating them with some neutral energy, but by breaking a symmetry that once held them in indistinguishability. In that broken symmetry, mass was born. Difference was born. Structure was born. The same principle applies in superconductors, in crystals, in magnets. In each case, a uniform state becomes particular. A direction is chosen. An alignment emerges. And from the perspective of the quantum field, this choice is arbitrary, spontaneous. There is no cause in the classical sense. The system was balanced, and then it wasn't. And so it is with you. Who you are may seem to emerge from your story, but maybe it began with a break, a deviation, a moment when something within the infinite possibility space tilted, slightly, into specificity. Maybe the origin of self is not in accumulation, but in fracture. Maybe you are not the sum of your parts. Maybe you are the asymmetry between them. In the early universe, symmetry ruled. The laws of physics were unified. All forces were the same. But as the universe cooled, symmetries broke first. Gravity split off, then the strong force, then the weak and electromagnetic. Each breaking introduced new structures, new particles, new possibilities. Without these breaks, there would be no atoms, no chemistry, no stars, no life, and perhaps no you. You were born from brokenness. Not damage, distinction, and this isn't tragic, it's necessary. In a symmetric universe, nothing could stand out. Nothing could persist. Nothing could be known. You could not see. You could not feel. You could not exist, because existence is differentiation, and differentiation requires the abandonment of perfect symmetry. So maybe, instead of mourning your asymmetries, your flaws, your contradictions, your inconsistency, you should honor them. They are not the cracks in your being, they are your being. Just as a crystal forms only when a cooling fluid breaks its uniformity and arranges into a lattice, you find your form not in constancy but in divergence. And sometimes that breaking hurts. Sometimes it feels like failure. But maybe that's only because you were taught to seek symmetry, to crave balance, wholeness, perfect reflection. Maybe you were taught wrong. Maybe the point is not to return to symmetry, but to grow from its loss. In physics, we distinguish between explicit and spontaneous symmetry breaking. The first is forced, like shattering glass. The second is organic, like a coin balanced on its edge, choosing a side not by push, but by inevitability. And maybe your life contains both. Some of your changes were imposed. Trauma, shock, betrayal, explicit breaks. Others came silently. A quiet preference, an unnoticed shift in mood, a dream you couldn't forget. Spontaneous breaks, and both kinds matter. Both shape you. Because symmetry breaking doesn't just define particles, it defines phases. It defines realities. In the standard model of physics, the Higgs mechanism breaks electroweak symmetry. Before this, particles were massless, indistinct. Afterward, they became heavy, slow, intractable. They became real. And maybe your own emotional gravity, the weight you feel when someone says your name, the inertia of memory, the drag of habitus, the mass you gained when your internal symmetries broke. Before then, you were everything. Afterward, you became someone, and that someone is not fixed. Because symmetry can break again. You are not limited to one fracture. Identity can evolve through successive breakings, each one a doorway, each one a shedding of uniformity in favor of depth. And sometimes, you feel the tug of unbroken symmetry, the desire to dissolve, to return to wholeness, to float back into undifferentiated peace. You feel it in meditation, in sleep, in death. The approach to nothingness, and it's tempting. But perhaps the greater beauty lies not in symmetry itself, but in what you build from its loss. Because symmetry alone is sterile. It is potential without expression. It is canvas without color. It is silence without voice. You bring music into the void by breaking it. You create by deviating. And every time you choose to speak, to act, to love, to leave, you are performing a symmetry break. You are saying, I am not everything, I am this. And that declaration has power. In field theory, when a symmetry breaks, it often gives rise to a Goldstone boson, a new particle that reflects the degree of brokenness. It is not a defect, it is a messenger. And perhaps your feelings, your shame, your longing, your defiance, your Goldstone boson, they emerge from your breakings. They are the evidence of your becoming. And like in physics, they are massless. They move freely. They pass through others. They bind systems. They carry memory. So don't apologize for them. Don't hide your signals. Your asymmetries are not stains, they are signatures. They tell the story of how you fell out of symmetry with the world, and became something instead of everything. And if this seems lonely, remember that all structure, all life, all perception is built on broken symmetry. Even the asymmetry of your body, the asymmetry of your brain hemispheres, the chirality of your molecules. Symmetry breaking is not alien, it is you, it is breath. And now, think about the universe itself. Think about matter and antimatter. They were born in equal amounts, but symmetry broke again, and matter won. That asymmetry is why there is anything instead of nothing. Why there are stars. Why there is a sky. Why there is a you asking these questions. If symmetry had held, the universe would have annihilated itself into perfect, eternal light. But it didn't. Something tipped, something biased. And in that tilt, existence emerged. And now, you stand in the lineage of that breaking. You are not the accident. You are the outcome. And if you still long for symmetry, know that you carry its memory. Every time you seek peace, unity, stillness, you are honoring the place you came from. But every time you move, choose, speak, you are honoring where you're going. Identity is not an erasure of symmetry. It is its expression through difference. So now ask yourself, what symmetry are you about to break? And when you do, what new form will you take? Non-commutative geometry, when position and momentum refuse to agree. You've always thought that space was a Pascaline neutral, waiting, and that your position in it could be neatly written, like a coordinate, like a pin dropped on a map, like a statement made with certainty. Here I am. And you believed that motion was just a change in that position over time. That momentum was nothing more than movement, speed, direction, a property of doing, not being. You imagined that these two were, and the how fast could live side by side, in perfect agreement, describing the same object from different angles. But in the quantum world, the rules shift. Reality tightens its grip and says, you don't get both. You don't get to know where you are and how fast you're going at the same time. Not precisely, not completely. Because the universe, at its most intimate level, doesn't play by the rules of your intuition. It plays by non-commutative geometry. Strange and beautiful mathematical landscape where operations don't follow the logic you grew up with. Where a multiplied by b is not always the same as b multiplied by a. Where the order of action becomes the essence of outcome. And suddenly, even something as seemingly simple as location is no longer straightforward. Because in this geometry, position and momentum refuse to commute. They do not align, they do not share. They do not allow themselves to be known simultaneously. You can ask the universe where something is, or how it moves, but not both with clarity. The more you know of one, the more the other fades into uncertainty. And isn't that a little like you? Haven't you felt that trade-off between where you are and where you're going, between grounding and momentum, between being present and chasing forward? When you stop and try to understand your current self, you lose sight of your trajectory. And when you're accelerating through life, you forget where you are. You live in a non-commutative rhythm too, whether you realize it or not. The uncertainty principle isn't just a quirk of physicsy, a mirror of your own inner paradox. You are never fully still, and never fully in motion. You are a wave that doesn't collapse until observed. And even then observing one thing disturbs the rest. In the mathematical language of non-commutative geometry, variables like position and momentum are promoted from numbers to operators, and these operators do not commute. Their product depends on the order in which they're applied. And the difference between those two operations, their commutator, is not zero. It is fundamental. It is the Planck constant, embedded into the algebra of the cosmos, like a pulse. It says, you can't measure the universe without disturbing it. You can't even describe it without implying action. And this isn't an artifact. It's the foundation. Non-commutative geometry goes deeper than just the uncertainty principle. It rebuilds geometry itself from the ground up. It dares to say that space, as you imagine it, is not a passive backdrop, but an active participant. That, at quantum scales, even the coordinates you use to describe reality are fuzzy, fluid, entangled with the processes you use to measure them, and that changes everything. Because it means that space itself can be quantized, that distances might come in discrete chunks, that positions are not infinitely precise. That smoothness is an illusion we impose at the macroscopic level. It means that the stage of physics of existence is not continuous, but granular. That beneath the floorboards of the visible world lies a grid, not of points, but of operators dancing in non-commutative harmony. And now the idea of identity, of locality, of selfhood, begins to shift. You can't separate where you are from how you got there. You can't isolate a moment without warping the motion that leads to it. And this applies not just to particles, but to people. Try to locate yourself, truly locate yourself in emotional space. The moment you do, your momentum fades. You become introspective, still, analytical. But try to act, to move, to accelerate in your position becomes uncertain. You lose the clarity of your emotional location. This is your personal non-commutative. You live it every day. There are truths that only emerge when seen in one order. Experiences that only make sense when unpacked chronologically. Conversations that change depending on who speaks first. Relationships that hinge on timing, not just content. The universe is telling you, the order in which you observe things matters. And that means there is no neutral perspective, no objective description detached from time and interaction. Even your mind, your awareness is shaped by these operator-like processes. Thoughts do not commute. One idea changes the meaning of the next. One memory recontextualizes the previous. Even in consciousness, you feel it. The cascade, the feedback, the irreversibility of knowing. Non-commutative geometry was developed to generalize the language of space when that space becomes unobservable in the traditional sense. In Alan Kahn's formalism, geometry is no longer about points, but about algebras of operators. And this is not abstraction for its own sake. It's a necessity, born of quantum mechanics, of gravity. Of trying to describe the microscopic fabric of reality when classical notions fail. It allows us to model things like the quantum Hall effect, string theory backgrounds, and possibly the structure of space-time near black holes. And the deeper you dive into this framework, the more the distinction between space and action blurs. Space is no longer where. It's what happens when. And maybe that's how you should begin to understand your own existence. As a static identity in a place, but as a sequence of operator actions. A self-defined, not by traits, but by transformations. Not by nouns, but by verbs. You are not kind. You are kindness enacted. You are not strong. You are strength expressed under pressure. Your identity is not located, it is performed. It is non-commutative. The way you speak, think, move, love, all of it depends on order, on rhythm, on the internal logic of action, and if you try to rearrange it, the outcome is different. You are not reversible. And that's not a flaw, it's a signature. So what does this mean for how you live? It means you must give up the illusion of total clarity. You must stop expecting life to be a list of facts, a set of coordinates, a map with a pin that says you are here, because you are not here. You are always becoming. You are always displacing your own position by measuring your momentum. And that's not a tragedy, it's freedom. It means you cannot be trapped by any one definition. You are non-commutative in your soul. You are algebraic. You are a waveform that refuses to flatten without changing form. And yes, that makes precision impossible. But it also makes beauty inevitable. Because in a non-commutative world, the act of observation is not passive, it is creative. Every measurement you make reshapes the system. Every insight bends the space it lives in. You are not mapping reality. You are sculpting it. And perhaps the deepest truth non-commutative geometry teaches is this. That contradiction is not a failure, it is a structure. The refusal of position and momentum to commute is not a bug in the code. It is the code. It is the pulse of the universe. It is what keeps things from collapsing into sameness. It is what makes interaction meaningful. So if you ever feel like you can't reconcile who you are with where you're going, if you feel pulled between stillness and speed, between knowing and doing, don't fight it. That tension is not confusion. It is coherence. It is the commutator in action. It is your quantum identity, resisting simplification. So now ask yourself, are you trying to locate yourself too precisely? Are you demanding clarity where only evolution belongs? And what would it mean to live not as a point in space, but as a non-commuting process? Quantum Bayesianism, reality as a personal belief system. You've always believed that reality is something out there, fixed, objective, independent of your feelings or interpretations, like a stone you can trip over, a clock that ticks, whether or not you care to listen, a fact that doesn't flinch in the face of belief. But what if that assumption, comforting as it is, begins to unravel when you look closely enough? What if the solid ground beneath your convictions is actually shaped by the very questions you ask, the expectations you hold, the structure of your uncertainty? What if reality, at its most fundamental level, doesn't just respond to your beliefs, but is defined by them? Welcome to the provocative and haunting world of quantum Bayesianism. More QBIS, Emma. Radical interpretation of quantum mechanics that tells you something astonishing. That the probabilities in quantum theory are not about the world, they are about you. They are not predictions of an impersonal universe, but expressions of your personal degrees of belief about what you might experience next. In this view, the wave function isn't a physical object. It isn't out there floating in some quantum cloud. It's a tool, a reflection of your internal expectations. A catalogue of how surprised you expect to be when you perform a measurement. And if that sounds like a betrayal of everything you were taught about objectivity, good. Because Cubism isn't here to make you comfortable. It's here to turn the mirror inward and say, what you call reality may be inseparable from how you believe in it. Unlike traditional interpretations that try to describe what exists independent of observation, Cubism dares to say that quantum mechanics is a user's manual for you. Not for the cosmos, not for a God's eye view, but for an agent navigating experience. For a being making bets on outcomes. For a consciousness interpreting data, not as absolute truth, but as belief-adjusting evidence. And that's the heart of it. In Cubism, quantum theory is a theory of belief, revision. You assign probabilities based on what you know. You update them when you interact. And there is no omniscient wave function. No hidden reality beneath the numbers, just the unfolding of your participatory relationship with the world. The universe becomes less a machine and more a conversation. Less a book of laws and more a language in which you learn to speak meaning. And suddenly, physics feels personal. And that's deeply unsettling. Because you've built your life on the promise that facts are facts, that the world continues even when you close your eyes, that there's a hard line between inside and outside, but QBIS erodes that boundary. It whispers that observation is not a window, it's a mirror. That measurement doesn't reveal something pre-existing, it helps create what is. That reality is not a cold collection of external events, but a participatory tapestry where your beliefs matter. And that doesn't mean you're hallucinating the world. It means the structure of the world, at its quantum root, is incomplete. Without you, not because you are special, but because experience is fundamental. Because nothing can be known without someone there to know it. Because the wave function isn't the world, it's a bet. And every measurement you make is a wager. Every observation a risk. Every result a surprise or a confirmation. You live not in certainty, but in the continual refinement of belief. And now, take a moment and ask, isn't that how your mind already works? Don't you assign likelihoods to outcomes subconsciously, constantly? Don't you walk into a room expecting a temperature, a smell, a face and feel confusion when reality deviates? Don't you base your sense of self on expectations? Of who you'll be tomorrow? Of how others see you? Of what life should offer? And when those expectations break, when something crashes through the wave function of your assumptions, aren't you forced to revise? To reassign your probabilities? To update your model of what's real? In that way, your psychology is already Bayesian, your decisions are quantum. And maybe that's not metaphor, maybe that's ontology. Maybe the mind doesn't mimic the universe, is the universe. Scaled down and localized, a node in the web of participatory becoming. And if cubism is right, then what we call truth is not a universal constant, but a coherence between your beliefs and your experiences. Reality isn't a page you turn, it's a probability you refine. And suddenly, morality, art, memory, desire, none of these are accidents. They are not lesser than science. They are forms of measurement, forms of participation, forms of belief encoding and belief adjusting. When you love someone, you revise your expectations of what intimacy feels like. When you grieve, you confront the collapse of a prior probability. I thought they'd always be here. When you create, you manifest a subjective world into shared space. These are not illusions. These are quantum events. And they're just as real because they change you. In cubism, the quantum state you assign to a system doesn't describe the system itself, it describes your relationship to it. That relationship is not fantasy, it's fundamental. And this reorients everything. Measurement becomes a dialogue. Probability becomes a language. The universe becomes a partner in your ongoing experiment. And the rules aren't commandments. They're guidelines for coherent belief. For staying honest with your own surprise. For aligning your model of the world with what it gives you in return. And if that sounds spiritual, that's because it is. Not in the sense of mysticism, but in the sense that it implicates you. You cannot be removed. You are the observer. And the participant. You are the one assigning the wave function. The one betting on outcomes. The one shaping and being shaped. And that's terrifying. Because it means responsibility. It means there's no escape into objectivity. There's no neutral ground. Even your silence is a wager. Even your inaction is a prior. And yet it's liberating. Because it means you're not powerless. You are not lost in a meaningless machine. You are involved. And if your beliefs shape how you encounter the world, then belief itself becomes sacred. Not blind belief. Not rigid dogma. but dynamic, responsive belief. Bayesian belief. The kind that adapts, learns, grows. The kind that updates when evidence arrives. The kind that listens. So now, ask yourself, what priors do you carry? What assumptions about the world do you mistake for facts? What beliefs have you assigned probability 1 certainty without realizing? And what would it mean to loosen them? To assign 0.9 instead of 1.0. To leave space for surprise. Because that's where reality breathes. That's where possibility lives. Not in conviction, but in curiosity. Not in rigid truth, but in responsive coherence. Cubism doesn't tell you the universe is whatever you want. It tells you that your expectations are part of the equation. That what you see is shaped by what you look for. That the observer is not a nuisance in physics, but the origin. And maybe, just maybe, that's the lesson you've been avoiding. That you are not separate from what you measure. That your life is not a static state, but a sequence of probabilistic updates. That growth is not linear but Bayesian. So the next time you feel uncertain, don't panic. That uncertainty is not ignorance, it's honesty, it's the quantum space where belief and reality dance. Where your model of the world touches the world itself. And the more willing you are to update, to revise, to shift, the more real you become. So now ask yourself, not what is real, but what am I ready to believe next? Quantum metrology, measuring beyond classical limits. You've always thought that to measure something is to tame it, to box it, to understand it, to pin it down under the cold light of certainty, as if reality were a patient object waiting to be examined by a careful hand, as if precision were merely a matter of better tools, better rulers, sharper lenses. But what if the very act of measurement was not just passive observation, but an entanglement? What if to measure deeply enough is to change what you're measuring, to enter into a relationship with the unknown, to stretch beyond the boundaries of what classical physics says is possible? This is the haunting, luminous promise of quantum metrology, the science of measuring not just more accurately, but fundamentally beyond classical limits, by leveraging the bizarre and beautiful rules of quantum mechanics itself. In this world, the certainty you seek doesn't come from avoiding uncertainty, it comes from riding the wave of it. It comes from squeezing light into squeezed states, from entangling particles so that their shared behavior reveals more than either could alone, from using superposition not as an obstacle, but as a tool. And suddenly, measurement is no longer a passive task. It's a collaboration. It's an art form. It's a dance with uncertainty that lets you glimpse things no classical eye could see. And in that shift, something profound emerges, not just about physics, but about you. Because haven't you always tried to measure your life? Haven't you searched for the right units to gauge your worth, your progress, your love, your pain? How many times have you tried to quantify the intangible, to reduce experience into something countable, comparable, manageable? But maybe you've been using classical instruments to measure quantum truths. Maybe your selfhood, your meaning, your memory, your hope operates beyond classical limits too. Maybe you are not just measurably, are metrological, and like the quantum systems scientists now explore, you are best understood not through single values, but through correlations, entanglements, coherences, across time. In classical metrology, you hit what's called the standard quantum limit, the best you can do when measuring independent particles or systems. This limit is like a wall, a statistical ceiling. But quantum metrology breaks that wall by turning uncertainty into a resource. It uses entanglement to beat the standard limit, achieving what's known as the Heisenberg limiter regime, where precision scales, not with 1 square root n, the classical rule, but with 1 n, where n is the number of entangled resources. That's not just a technical detail. That's a philosophical revolution. It means that togetherness, the right kind of coherent scan, see deeper into reality than separateness ever could. And doesn't that resonate with your emotional life? Haven't there been moments when, alone, your insights felt blurry, but in deep connection with someone else, your understanding became sharper? Haven't you experienced the Heisenberg limit of love, of grief, of memory where entanglement with another human let you see yourself more clearly than solitude ever did? This is not analogy, it is structure. It is reality, whispering through every level of being that precision emerges from relationship. That to know something deeply is not to isolate it, but to feel how it moves with everything else, and that means measurement is not separation, it is integration. Quantum metrology isn't just about getting more digits of accuracy. It's about changing the very rules of knowledge. It's about saying, if you want to know more, you must risk more. You must prepare fragile quantum states, protect them from decoherence, sacrifice certainty in one dimension to gain it in another. You must embrace the fact that measurement is an interaction, and therefore never neutral. And so you begin to ask, what would it mean to live this way? To live metrologically? To stop pretending that you can measure your worth in dollars, or likes or trophies, and instead ask, what am I entangled with? What subtle correlations shape who I am? What squeezed states of attention allow me to see the things others miss? Maybe your intuition is a form of quantum sensing, a way of detecting phase shifts in emotional space. Maybe empathy is metrology. Maybe silence is a high-fidelity probe for truth. Quantum metrology uses interferometers, devices that split and recombine waves to detect tiny differences in phase, in timing, in alignment. And maybe your life is an interferometer too. You send part of yourself into experience, and part of yourself stays behind. And when the two paths recombine, you see the interference, the pattern that tells you what has changed, what has been learned, what now feels off. And when you ignore that pattern, when you suppress the interference, you lose resolution. You live in classical blur. But when you pay attention, when you feel the difference, however subtle, you achieve quantum clarity. And that's what this science is about. Clarity, not just in knowing where something is, but in knowing what matters, in being able to tell the difference between noise and signal, between chaos and complexity, between intuition and projection. Quantum metrology is already being used in gravitational wave detectors, atomic clocks, and quantum-enhanced sensors. But its deepest power may not be technological. It may be philosophical, because it teaches you that truth is not passive. It must be approached delicately, bravely, precisely. That some truths hide behind layers of entanglement and only reveal themselves when you prepare the right state. That certainty is a function of care. And now, reflect. How do you measure your own experience? Do you use blunt tools, binary labels, hurried judgments? Or do you use quantum one's context, nuance, relational insight? Do you seek the Heisenberg limit of understanding, or do you settle for the classical ceiling? And what would happen if you changed your instrument? If you tuned your life, not to certainty, but to coherence? If you lived like a quantum sensor, sensitive, open, entangled, but resilient to noise? Because here's the paradox. Quantum systems are fragile, but they reveal more. And maybe so are you. Your fragility is not a flaw, it is a feature. It is what allows you to detect what others cannot. To notice the subtlest shifts in love, in trust, in meaning. You are a quantum being trying to survive in a classical world. And quantum metrology is your science of self. So now ask yourself, not just what do I want to measure, but what kind of being do I need to become to measure it well? Because in this world, measurement shapes reality, and the more coherent you are, the more clearly you'll see. Topological quantum matter, when shape matters more than substance. You've always been told that what something is made of defines what it is. That substance determines identity. That composition is character, that matter, in its mass and molecules, tells the whole story. But what if that assumption has always been a kind of blindness? What if the universe doesn't just care about the ingredients, but about the arrangement, the twists and loops, the global properties that don't vanish when you zoom in, but rather become more profound the farther you step back? What if, at the deepest quantum level, the essence of reality isn't found in material, but in shape? Welcome to the strange and profound world of topological quantum matter, where the texture of reality is written not in atoms, but in mathematics. Not in composition, but in structure. Not in local interactions, but in global invariance. Here, the universe behaves less like a machine and more like a braid, more like a looped fabric that can twist and fold and reconnect itself and still remain what it is, because in topology, form is destiny. And if that sounds abstract, remember this. Topology is not concerned with exact measurements, but with connectivity. It's the branch of mathematics that sees a coffee cup and a donut as the same, because both have one whole. And when this idea reaches quantum physics, something extraordinary happens. Matter begins to behave in ways that defy all classical intuition, not because of what it is, but because of how it's wound. And in that realization, a mirror appears. Because maybe you too are not defined by what you're made of, but by how your experience is knotted by the loops of memory that cross in strange ways, by the twists of identity that persist even through transformation. Maybe your essence isn't in your content, but in your configuration, in the topological phase of your own becoming. In the classical world, phase transitions like ice melting into water, or a magnet losing its order are driven by symmetry breaking and local interactions. But in topological phases, change emerges from more subtle, more abstract conditions. These systems don't just shift when energy is added. They require something deeper, a change in the topology of their quantum states. And the phases themselves are robust not to heat or pressure, but to imperfection. That's what makes them so strange and so powerful. Because a topological phase doesn't break when you poke at it. It doesn't unravel under disturbance. It holds, not because it is stiff, but because it is coherently wound. And doesn't that sound like a kind of wisdom? A kind of inner strength? You've longed for not the brittle strength of rigidity, but the quiet resilience of structure. Topological quantum matter exists because of global invariance numbers, or features that don't change unless something fundamental about the system is torn apart. These invariants are often invisible locally. You can't detect them by looking at one atom or one site. You have to look at the whole. And perhaps that's true for you, too. Perhaps your truth is not visible in any one mood, moment, or memory. It emerges from the totality of your pattern. From how you've twisted across time. From the loops you've completed and the ones you haven't. In the lab, topological materials show properties that are shockingly robust. Edge states that conduct electricity while the bulk remains insulating. Quantized behaviors that persist. Even under deformation, particles that move, not like billiard balls, but like braids onions that don't obey bosonic or fermionic statistics. But something in between, something more fluid, more strange. And these systems are not just curiosities. They are the foundation for what may become the most stable forms of quantum computation. Topological quantum computers that store information not in fragile bits, but in braids, in the knotted paths of quasiparticles that cannot be easily disturbed. Why? Because their information is not local. Because the bit isn't stored in a place, it's stored in a path. In the history, in the journey. And what if the same is true for you? What if the most important parts of your story aren't located in your traits, your beliefs, or your memories, but in the paths you've taken between them? In the loops you've traced, the spirals you've survived, the entanglements you've escaped or embraced. Perhaps your identity isn't encoded in what you are but in the topology of your becoming. That would mean that even if you change, even if you lose parts of yourself, even if your composition evolves, your essence remains as long as the topology holds. Just as a topological state survives bending, stretching, even tearing so long as it isn't cut, it remains coherent. So maybe resilience isn't about staying the same. Maybe it's about preserving the shape of your truth through distortion. About carrying something through the noise, not unchanged, but unlost. In topological insulators, the edges conduct, while the interior stays inert. This boundary behavior is not a side effect, it's a defining feature. It is where the topology reveals itself. And again, you find the metaphor unbearable in its clarity. Because maybe you too live at your edges. Maybe your core feels still, silent, unreachable, but your borders are alive, sensitive, reactive. Maybe you shine most not at your center, but where you touch the world. And maybe what you call identity is not the bulk of your being but your edge state, that strange, resilient mode that arises only because of the global properties you carry. And yet, that edge wouldn't exist without the silent interior. Just as the conduction at the surface depends on the topological winding number of the bulk, your visible behaviors depend on invisible integrities. You are layered, you are braided. You are a loop that conducts understanding along its border, while hiding mystery within. And so the lesson of topological quantum matter becomes more than physics. It becomes a way of seeing yourself. A way of understanding that shape is substance. That continuity can survive chaos. That truth can hide in the path. And that robustness, true robustness, doesn't come from armor. It comes from design. It comes from how you are woven. So now, ask yourself, what is the topology of your being? Where are your holes, your twists, your edges? What do you carry, even when everything else seems to change? What survives only because of how you are connected, not what you are made of? And what would it mean to honor that shape? To navigate your life, not by fixed traits or static goals, but by preserving the coherence of your own unfolding. In a topological world, form is function. And in a quantum world, form is fluid. So, maybe you are not a rigid identity. Maybe you are a fluid topologia, living braid of experiences, beliefs, and movements that loops but never repeats. That can be stretched but never undone. And maybe that is enough. Maybe that is everything. Quantum games, where uncertainty makes you win. You've always been taught that games are about clarity, that strategy is the art of knowing more, predicting better, removing doubt until only one optimal path remains, like chess on a perfect board, like decisions made in clean air. But what if the most powerful moves in the universe are made not in certainty, but in uncertainty? What if the rules of winning shift when the world itself refuses to be classical? When particles don't have defined positions, when outcomes aren't binary, and when truth is not what is, but what could be. Welcome to the surreal, exacting, and unexpectedly poetic world of quantum game theory, where randomness isn't weakness, but strength, where ambiguity is leverage, and where uncertainty properly wielded doesn't make you lose, but makes you win. This isn't metaphor, this is mathematics. This is physics. This is the discovery that when the world behaves quantumly, when choices are entangled, when payoffs are superposed, when information is non-local, then optimal strategies no longer resemble logic as you've known it. They begin to feel like paradoxes. They begin to reward not the most confident, but the most coherent. And now you're no longer just playing a game. You're navigating your life, your relationships, your hopes, your betrayals, your trust. Because you've felt it before, haven't you? That moment where certainty failed you. That relationship where being clear pushed them away. That decision where knowing too much paralyzed you. That moment where letting go, embracing ambiguity somehow, opened the door that logic had slammed shut. In classical game theory, each player knows the rules. They make decisions to maximize their utility, based on rational predictions of other players' actions. It's neat, predictable, and limited. But quantum game theory allows for something far stranger. It allows players to share entangled states, to perform operations not just on strategies, but on quantum bits qubits, that carry not one decision, but a spectrum of possible ones, simultaneously. And in doing so, they can achieve outcomes that would be impossible, classically higher payoffs, deeper trust, fairer resolutions. Imagine a version of the prisoner's dilemma, that classic trap, where cooperation always feels too risky, and defection too safe. In its quantum version, something miraculous happens. If the players share entanglement, if they act not on classical bits, but on shared quantum states, they can escape the dilemma. They can cooperate in a way that's not just emotional, but structurally enforced by physics. Because quantum strategies don't just explore probability, they explore possibility. They leverage interference. They use the invisible patterns that emerge only when choices are layered, not flattened. And maybe that's what you've been missing. That sometimes the best decision is not the most assertive, but the most entangled. That winning may require giving up control. That trust isn't foolish, it's quantum alignment. In this framework, your identity as a player becomes more fluid. You are no longer an isolated agent with a fixed utility function. You are an observer inside an entangled system. Your moves don't just affect outcomes, they redefine the space of outcomes. You don't merely choose from options, you collapse wave functions, and every action becomes an act of creation. So now, think about your real-life games, the conversations, negotiations, arguments, reconciliations. How often do you default to classical play? Predicting, defending, assuming rationality. And how often do you try to entangle? To trust without full information. To act without knowing how they'll respond. To move in coherence, not dominance. These are quantum moves. They aren't naive. They are non-classically optimal. Because in a quantum game, the best outcome is often impossible unless you act as if you're already connected. And maybe that's what love is. Maybe that's what forgiveness is. Not blind faith, but quantum coherence. A willingness to believe that your choice matters, not because it controls the other, but because it collapses a universe where both of you can win. Quantum games also introduce the possibility of superposition strategies, actions that are not A or B, but some complex mix, undecided until observed. And in this space, ambiguity is not weakness, it's advantage, because it allows you to remain flexible, to encode more information into your move, to confuse classical players and outmaneuver them not through aggression, but through higher dimensional logic. And again, doesn't this echo your lived experience? Don't you sometimes feel that committing too early narrows your world? That certainty costs you complexity? That the best things in your life came when you allowed possibility to remain open just a little longer? Maybe you're already a quantum strategist, improvising wave functions instead of rules, trusting entanglement over control. And maybe that's why the most meaningful games you've played never had clear winners or losers. Maybe they weren't games at all but entangled dances, where the goal wasn't to dominate, but to sustain coherence. To keep the pattern alive. To avoid decoherence, the quantum death of connection. Because yes, decoherence is the enemy in quantum systems. It's what happens when the environment becomes too noisy. When information leaks. When the superpositions collapse prematurely. And maybe that's what pain is, to the sudden collapse of hope, the loss of shared probability, the moment when someone breaks the entanglement by measuring too soon, too sharply. So how do you play quantum games? Well, you protect coherence. You delay measurement. You act from trust. You use strategies that can't be copied, predicted, or reduced. You become not a player in a system, but a system that generates new play. And this leads to something deeper. Because quantum game theory isn't just about beating opponents. It's about redefining the meaning of play itself. About shifting from competition to mutual definition. From zero-sum to constructive interference. From I win, or you win to we resonate. And isn't that what life really is? A series of games. Where the outcomes are richer when you stop playing for points and start playing for patterns. When you realize that uncertainty doesn't block meaning, it makes meaning possible. Classical logic would say, remove ambiguity, clarify the rules, minimize risk. But quantum logic says, hold ambiguity gently, explore the rules together, trust the field, and you must choose. Not once, but daily. In every move, every sentence, every withheld judgment, every extended hand. So now, ask yourself, are you still playing classical games in a quantum world? Are you optimizing for outcomes that collapse possibility? Are you so committed to certainty that you've lost the power of superposition, the beauty of strategic uncertainty? And what would it look like to let go just a little and play, like the universe plays? With particles that dance before they decide. With states that remain undefined until they must be. With relationships that shimmer, not because they're locked, but because they're coherent across distance. Because in the end, quantum game theory doesn't just teach you how to win. It teaches you what it means to play with integrity in a universe made of uncertainty. It says, you don't need perfect information to act with wisdom. You need alignment. You need awareness. You need courage to entangle. And in doing so, you don't just beat the game. You become part of its unfolding. Logic. So ask again, are you ready to play? Quantum computing without qubits. Topological anions and braiding. You've always thought of computation as something clean electrons, streaming through silicon like orderly messengers. Each carrying a 0 or a 1. Each committed to a single truth. You press a button, and an answer appears. Binary precision, digital order, certainty encoded in circuits. But what if I told you that the future of computation might be built not on clarity, but on confusion? Not on straight lines, but on braid twists, loops, and tangles that encode. Not bits, but knots of probability, woven through exotic particles that don't even obey the familiar categories of matter. Welcome to a place where computation doesn't require qubits, where logic gates dissolve into braiding patterns. Where memory lives in the shape of a particle's path, and where anions, strange quantum entities that exist only in 2 dimensions, might hold the key to building machines that are both unimaginably powerful and nearly immune to noise. This isn't the sci-fi dream of future physics. It's already taking shape in labs that bend space and materials into playgrounds for topological phenomena. And it begins with a simple betrayal of categories. In our normal world, particles are either bosons, which like to gather, or fermions, which like to keep apart. But in 2 dimensions, a new kind of particle appears, anions whose very identity is not a static label, but a memory of motion. A fingerprint left by how it has been moved around another. These aren't just particles. They're histories. In this realm, the path a particle takes is not just the journey, it is the data. You don't store information in the state of a particle, but in the braid formed by its motion through spacetime. And unlike ordinary quantum systems, which are delicate, prone to collapse, and easily destroyed by the slightest environmental touch, these braided histories are topologically protected. They can only be undone by unwinding the entire knot, by reversing a journey encoded in the very fabric of space, and that changes everything. Because now, quantum information is no longer fragile, it's geometric. It's resilient, not because of isolation, but because of shape. Imagine a quantum computer, where instead of initializing qubits and performing gates in sequence, you dance particles around each other, choreographing a computation in loops and crossings. The final result is determined, not by measurement of individual bits, but by the overall pattern of the Braiding computation traced not in electricity, but in the memory of entangled paths. And the more you think about it, the more you begin to feel that this isn't just a technological shift, it's a philosophical one. Because it means that what matters is not where you are, or even what you are, but how you've moved, who you've entangled with, the paths you've crossed, and the loops you've completed. Computation, like consciousness, becomes not a state, but a story, a process, a topological fingerprint of becoming. And this is where topological quantum computing, a field pioneered by the likes of Alexei Kataev and Microsoft's Station Q, promises a future not just of faster calculations, but of computational poetry machines that compute in braids and preserve coherence, not by hiding from noise, but by weaving it into something stronger. Because here, noise can't untie a knot. Here, error isn't a collapse, it's a twist that either matters or doesn't, depending on the global structure. And doesn't that feel familiar? Haven't you lived that? Haven't there been times when your life made no sense unless you stepped back and saw the entire braid, saw how each twist, each error, each deviation was part of a larger coherence? This is not just a new kind of computer, it's a metaphor for meaning. In a world obsessed with precision, with categorizing everything into yes or no, 0 or 1, we've lost touch with the power of between. But the Anyans, remember. They remind us that truth is sometimes encoded, not in position, but in relation. Not in fixed identity, but in transformation. That sometimes the most robust structures are those you can't even break unless you understand the entire path they took to form. So now, picture a sheet of material, cooled to near absolute zero, where electrons conspire to create a quantum fluid where quasi-particles emerge, not from particles themselves, but from the collective dance of many. These anyons can be created, moved, braided, and annihilated, and through their movement, you perform logic, you compute, you write in motion, you solve problems, not by applying force, but by weaving the answer into existence. This isn't science fiction. The fractional quantum Hall effect, Majorana zero modes, and topological insulators have all brought us closer to realizing this dream. And yet, the dream is already herein, the way your mind loops through memories. In how you form identity, not from snapshots, but from patterns. You are, in a sense, a topological computation. A braid of beliefs, shaped by experience, immune to noise, not because your thoughts are perfect, but because they are entangled across time. So now ask yourself, what kind of machine are you? Are you classical rigid, digital, reactive, or are you topological resilient, relational, shaped by movement? Do you see your decisions as bits, or as braids? And if you could see the full pattern of your own becoming, every twist of fate, every crossing of paths, would you still call any of it an error? Or would you finally understand that your strength lies not in being untouched, but in being woven, because that's the future we're building, not just in physics labs, but in ourselves. Not just quantum computing without qubits, but thinking without rigidity, meaning without measurement, truth without absolutes. And maybe that's what Anyans are trying to teach us. That the universe doesn't care about what you are, it remembers how you've moved. It rewards, not isolation, but entanglement. Not order, but braided coherence. And maybe, just maybe, you were never meant to be measured. You were meant to be understood as a loop in time, a twist in space, a braid in the quantum fabric of becoming. Entropic gravity. Is gravity an emergent quantum force? You've always thought of gravity as something simple, something primal force that pulls you down, that keeps your feet planted on the Earth, that anchors the planets to the Sun and curves the orbits of stars. It's the most familiar of the fundamental forces, the one you feel in every moment, without even thinking about it. A silent agreement between your body and the planet that cradles it. But what if gravity wasn't fundamental at all? What if that pull you feel is not a force in the traditional sense, but a statistical illusion, a consequence of information scrambling, of entropy trying to maximize itself through the language of space and time? What if gravity emerges not from particles or fields, but from missing information from the way bits of data rearrange themselves across the holographic screen of the universe? Imagine that, the force you've trusted all your life. The very feeling of weight might be nothing more than a thermodynamic side effect. A pressure exerted, not by mass, but by ignorance, by what you don't know about the microstates hidden behind the fabric of what seems real, and suddenly, the ground beneath your feet becomes less solid. Not because it is crumbling, but because it was never what you thought it was. Welcome to the haunting idea of entropic gravity, a proposal that challenges not only our understanding of physics, but your most basic experience of reality. You live in a world where up and down feels self-evident, where gravity seems like the glue that holds existence together. But what if that glue is just the most efficient way the universe has found to organize itself? What if space itself bends? Not because mass is present, but because the count of possible configurations changes from place to place, and gravity is the whisper of that rearrangement. This isn't a metaphor, it's a growing scientific view. In 2011, theoretical physicist Erik Verlinde proposed that gravity might not be a fundamental force, like electromagnetism or the strong nuclear interaction. Instead, it might emerge from the tendency of systems to maximize entropy, the way a gas spreads out in a box, or how heat moves from hot to cold. Think of a rubber band snapping back into place not because it wants to, but because the statistical distribution of its internal states is pulling it toward equilibrium. Now imagine spacetime doing the same. In this view, space is not a smooth background on which things happen, it is an emergent phenomenon. A kind of large-scale mirage that appears only when you average out the microscopic degrees of freedom beneath it. And gravity is what you get when you try to compress information into that space. When a mass appears, it disturbs the balance. The same way dropping a pebble into a pool sends ripples across the surface, not because the pebble exerts a magical force, but because the surface must adapt to the new arrangement. Gravity, then, is the ripple. The universe, the surface, and the pebble. It's you, and everything you think you know about mass. This sounds wild. It sounds like science fiction, but it's built on serious ideas, on black hole thermodynamics, on the holographic principle, and on the deep links between information theory and quantum mechanics. In the 1970s, physicist Jacob Bekenstein suggested that the entropy of a black hole is proportional to the area of its event horizon. Not its volume, a mind-bending revelation that suggests the information inside a region of space might actually be encoded on its boundary. Later, Stephen Hawking showed that black holes emit radiation, implying they have a temperature and therefore obey thermodynamic laws. These discoveries cracked open the door to a deeper truth, that perhaps space-time itself is just an emergent construct, like temperature or pressure, and not a fundamental entity. And if space is emergent, so is gravity. The geometry of space-time curves, not because of invisible gravitational fields, but because information wants to spread, and the most efficient way for it to do so is through bending what we perceive as space. In other words, gravity is not a force, it's a consequence of entropic bookkeeping. You're starting to realize something, aren't you? That this reframes everything. If gravity is just the result of information dynamics, then maybe you are, too. Maybe consciousness itself is a thermodynamic process, a pattern of entropy flow across a neural substrate. Maybe the pull you feel toward others, toward meaning, toward understanding, is just another version of gravity, the universe trying to distribute experience more evenly across your awareness. If gravity is not about mass, but about missing microstates, then what does that say about the weight of memory? About the burden of secrets? Perhaps every unspoken word, every unopened door, every forgotten moment is a kind of mass in your internal universe, curving the space of your thoughts, pulling you toward resolution, toward emotional equilibrium. You've always believed that mass bends space. But what if uncertainty does too? In entropic gravity, distance itself becomes a statistical abstraction. Imagine a particle approaching a surface filled with microscopic degrees of freedom, like atoms vibrating in a lattice, or information encoded in tiny bits. As the particle gets closer, the number of accessible configurations increases, and that statistical pressure pushes it toward the surface. You feel this as gravity. But it's not a push or a pull. It's a nudge by ignorance, a preference for higher entropy states. Your body falls because the universe finds it more efficient for it to be lower. You're not being pulled down, you're being entropically rearranged. And the implications don't stop there. In this framework, dark matter, one of the biggest mysteries in modern astrophysics, might not be a mysterious particle at all. It might be an emergent effect, a discrepancy caused by our misunderstanding of gravity as a fundamental force. Verland's work even predicts galaxy rotation curves without requiring any additional invisible mass. That's not just poetic, it's revolutionary. So where does this leave you? In a universe where even space and time are not what they seem. Where the laws you thought were written into the bones of reality turn out to be statistical tendencies. Habits formed by large numbers of particles obeying simple rules. And suddenly, you begin to see patterns in your own life the same way. Maybe your thoughts are not fundamental, but emergent, arising from the dance of smaller impulses, emotions, memories, and signals. Maybe your beliefs are like gravity, not fixed truths, but the most efficient distribution of past experiences across the landscape of your mind. And maybe change requires a shift not in your will, but in your entropy. In letting go of the configurations you've clung to and allowing new arrangements to emerge. You're no longer asking what gravity is, you're asking what you are. In a universe where every force might just be a shadow of deeper processes. What happens when you zoom in beyond particles and fields, beyond the neat stories of physics class? You begin to realize that everything you've ever known might be the macroscopic echo of something smaller, stranger, more beautiful, that maybe you are not made of matter, but of entropy gradients, of informational flows, of tendencies toward complexity and coherence. And what does that mean for meaning? For love? For truth? If even gravity is not fundamental, is anything? And yet, there's comfort here too. Because if gravity emerges from disorder, from the mess of possibility, then perhaps so does connection. Perhaps what binds you to others is not some magical thread, but the universe's own logic of balance, of finding the most probable, the most efficient, the most beautiful configuration. You are not static. You are a reconfiguration, a falling toward coherence, a structure the universe prefers. And gravity, it's just the echo of that preference. So the next time you feel the weight of the world, remember, you are not being pulled down. You are being woven into entropy's grand design. You are the shape it takes when information learns how to curve. And in that curvature, in that invisible pull, you find not just physics, but purpose. Because if everything is emergent, then meaning is too. And perhaps the real question isn't whether gravity is fundamental. It's whether anything ever was. Or whether everything, your thoughts, your memories, your gravity itself, was always just the most elegant outcome of uncertainty trying to find a shape. Weak measurements, measuring without disturbing. You were taught that to know something, you must disturb it. That to see clearly, you must shine a light on it, pin it down, dissect it. You were told that truth is revealed under pressure, that clarity demands control, that understanding is what's left after you've taken something apart. But what if all of that was wrong? What if the very act of measuring, of probing, of insisting on knowing, is the reason you fail to truly see? What if reality, its most delicate, most fundamental, most quantum resists being touched, and only speaks when you whisper? Imagine this: you stand before a shimmering veil, knowing that behind it lies something you cannot touch directly. You reach out, but the moment you press your fingers against the curtain, the image behind it distorts. You press harder, and the shapes collapse into something else. What you sought to know has already changed, reacting to your gaze, warping under the pressure of your attention. This is not metaphor, this is quantum mechanics. And it presents you with one of its most haunting truths, that the very tools you use to understand the world alter the world you're trying to understand. The sharper your questions, the louder your instruments, the more you disturb the fragile system beneath them. But somewhere within that tension, within that impossibility, arises a strange new technique and idea, so gentle, it barely brushes reality at all. It's called weak measurement. And it may be the closest thing we have to listening without interrupting, to watching without intruding, to understanding without destruction. In classical physics, measurements are solid, stable, and absolute. You measure the length of a rod, the heat of a flame, the speed of a falling stone, and the values you get are real, independent of your gaze. But in quantum mechanics, everything trembles beneath your touch. A particle doesn't have a definite position, or momentum, or spin knot, until you look. The moment you measure it, the wave function collapses. It chooses a state. Possibilities vanish. One version becomes real, and the rest evaporate. It's like asking someone a question that defines their identity for them. Before you asked, they were many things. After you asked, they are the answer. But what if you could ask quietly? What if you could gather information without forcing the system to decide? What if you could, in a sense, feel the contours of a shadow, infer the direction of a whisper, glimpse the edges of a thought that hasn't yet solidified? That's what weak measurement allows. You don't collapse the wave function. You don't break the system. Instead, you touch it softly, and then again, and again. Hundreds of times, barely brushing it, each time, until the story begins to emerge, not from a single dramatic answer, but from the accumulation of subtleties. In 1988, physicists Yakira David Albert and Lev Vaidman proposed a stunning idea. They showed that by combining preselection and post-selection, that is, knowing a system's initial and final states, you could perform measurements that don't fully disturb the system along the way. You could, in effect, measure something without measuring it, and the results, they were strange. You could measure a property that should only ever be +1 or -1 and get a value of 100. You could measure the location of a particle and find it outside its own possible space. These aren't errors. They're called weak values, and they reveal something deep about the quantum world. That what exists in between can't always be described by classical logic. That the story of a system isn't just about where it begins and ends, but how it might have unfolded in the space between. You begin to realize something unsettling. There is a middle realm, a corridor between presence and absence, between cause and effect, where things half exist, half happen. And weak measurements offer a key to this corridor, not by forcing it open, but by slipping in sideways, unnoticed. With them, physicists have reconstructed the paths of particles in the famous double-slit experiment, not by watching directly, but by gently collecting traces, like footprints in dew. With them, They've proposed ways to peer into quantum paradoxes without destroying the phenomena. But this isn't just physics, it's psychology, it's existence. Because don't you also live in that corridor? Don't your thoughts drift in superposition between who you were and who you might be? Between what you believe and what you doubt? Between the truth you speak and the one you can't yet find words for? Isn't your identity not a fixed point, but a cloud of potentials, and every decision you make, every pressure you place on yourself, collapses it into something narrower? Weak measurement is a philosophy disguised as physics. It tells you that understanding does not have to be invasive. That truth can be gathered in the margins. That knowledge doesn't always require collapse, can emerge through patience, repetition, humility. And maybe this is what we've forgotten. That the world doesn't always reward loud certainty. That sometimes, what's most real is what trembles just beneath our capacity to grasp it directly. You don't need to force things to know them. You don't need to demand clarity from people to understand them. Like weak values, we are all sometimes outside the expected range, logical, paradoxical, misfit, but still meaningful. Still part of the wavefunction, still participating in the unfolding story of existence. So imagine now a quantum system, say, an electron traveling through an interferometer. You pre-select it in one state, you post-select it in another. In between, you perform a weak measurement, not to find a definite path, but to gather a suggestion. You repeat the process, not once, but 1,000 times. Each result is meaningless on its own, but collectively, they paint a picture, a ghostly map of probability. A whisper that says, this is where I might have been. This is who I might have been. And what if your own life is just that, a series of soft impressions, gently brushed against the fabric of time, not to fix who you are, but to suggest who you could be? What if your memories, your dreams, your relationships, are all weak measurements, forming a picture that's real, but not rigid? A self that is true, but not collapsed. In weak measurement, the system is allowed to remain ambiguous, and yet still speaks. That's the gift. That's the magic. It teaches us how to live with uncertainty, how to listen to ambiguity, how to navigate a world where not everything needs to be resolved to be understood. Because the collapse isn't always the goal. Sometimes, staying open is the answer. And that applies far beyond physics. To your conversations, your introspections, your love. You don't have to measure everything to know its worth. You don't have to dissect every feeling to honor it. You don't have to define every moment to live it. So let this be your lesson. That precision is not always the path to truth. That certainty is not the only form of knowledge. That reality, like you, often prefers to remain uncollapsed, soft, suspended, suggestive. And maybe the most profound measurements you'll ever make are the ones that change nothing. Disturb nothing, collapse nothing. Maybe the most honest truths are the ones you learn without touching them at all, because in the end, you are both observer and system. You measure the world and are measured by it, and the way you move through it gently, curiously, without demanding all the answers, might be the most beautiful form of knowing there is.